Furthermore, I will have many presentation at this event as well. We would like to invite the honorable guests to listening the following various our four topics. First topic is smart technology in forestry and agriculture. The second topic is climate smart solution for future agriculture and forestry. The third topic is smart forestry agriculture management for carbon subscription. The last one topic is water and environment for climate realizing. Okay, one discussion. I would like to invite the Dean of the Grad School, Kochi University, to kindly deliver welcome to remark. Ladies and gentlemen, please give a warm welcome to Associate Dean, Associate Professor Dr. Viraphat Khun Ratanasiri.
Good morning, the delegate from Kengsang National University and Kochi University. I would like to officially welcome you to the International Joint Seminar in 2024, Smart Forestry, Agriculture and Water Management in Climate Change Era. First of all, I would like to give you a brief introduction of the Kasetsart University. The establishment of Kasetsart University was part of the evolution of agricultural education in Thailand, which began with the founding of a system of technical school. The goal of Kasetsart University, we try to promote the knowledge of the land for the well-being of national and global community. When we're talking about Kasetsart University, we are very proud that we are number one in agriculture and forestry university in Thailand, and number 11 in Asia, ranked by QS World University ranking by subject. We are number one green university in Thailand and number 38 in the world ranked by UI Green Metric World University ranking in 2023. Now, Kasetsart University moved from the agricultural science into the health science. The university have established the Faculty of Medicine. KU accepted the first batch of 47 new students in the first semester this year. I would like to give you the objective of the graduate school. We are now set 3 objectives of the graduate school. The first, we would like to develop the quality and standard of graduate students. The second is we need to support our lecturer and graduate students in reaching their full potential with limited resources. And the last, we would like to develop and improve the efficiency and effectiveness of an auditable administrative system with the equality for all staff members for the approach of the ASEAN Economic Community together with social responsibility and awareness. When we're talking about climate change, that means in this situation, we have very high concern of the rising of the climate change nowadays. When we're talking about our world with the global warming, global boiling, and so on, this is still the issue that we need to seek for the answer for the climate change problem. Thanks to Assistant Professor Dr. Nalumon Keo Champa. Thanks to Assistant Professor Dr. Piyapong Thongdinok to join with us today. And both of you is the key person to conduct this kind of the seminar with three universities. Thanks to the SLUS program under the graduate school to play the role to introduce you with the program when in the future maybe some of the Gyeongsang students or some of the Kochi University students would like to attend for the master degree in the future. We would like to welcome both of you when you thinking about for the new student enroll for the master degree students or doctoral students. The time is now ready to open for this seminar. I hope that this seminar will can reach the object that you set, and all of the students will have a floor for the exchange in terms of education purpose or for the cultural exchange. So we are now have the Thai students, Korean students, and also Japanese students. We have 1 day of the seminar. The time is ready for you, for our students. The last thing is, Kasetsart University set goal by student-based approach. That means when we looking about the student, we need to prepare some for student that is the best for the university. This floor is for you, for exchange, for learning together, and hope you will success with the objective of the seminar, and hope that you spend the time in Thailand with happiness, and hope that you come back to your homeland safe and good journey. Thank you very much.
Okay, thank you very much, Dr. Kunlanasili, for welcome remark. The next sequence, may I invite all participants combined with our speaker, which take a good photo. Please get the sit up at your seat, at your desk, or our photography will take a moment. Please, sir. Okay. 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 Thank you very much for her guests. Okay, the next sequence is a key essays on the topic titled as Introduction to the Sustainable Land Use and Natural Resource Management Program and Challenge of Research which is presented by Associate Professor Dr. Parishat Promchod, Chairman of the Sustainable Land Use and Natural Management Program. Please, I would like to invite you to Dr. Promchod.
Okay, good morning for all professors from Thailand, Japan, and also from Korea. Also, good morning for everyone as graduate student. I hope that we have undergrad student too. Just make me feeling when I was student. So today is very pleased to have opportunity to introduce the Sustainable Land Use and Natural Resource Management Program and the challenge of the recent research. So I will take about 15 minutes for introduction and hope that everybody will understand about, we call the short name as SLUS. SLUS is just a short name of our program. So first of all, I would like to introduce about the KU SLUS, the history. Actually, it's very long history, not too long as Kochi University, just about 20 years ago that we got contract from University Consortium in Denmark that would like to work on sustainable land use and natural resource management. And then they contact to us as a key leader in Thailand. So KU just have a joint working with many partners in Thailand, including Chiang Mai University, Metro University, Royal Forest Department, and Land Development. So at that time, we call ourselves as two-set SLUS. So when we start up for the consortium working, we also have international consortium from Malaysia and also from South Africa. We got support from Danset or Dadida now from Denmark to have the mission for capacity building in education, joint research and joint field course, and also curriculum development. So at the first time, we call for application from many faculty at KU and also partner in Thailand to have a joint field course together. Also, international students come to us and have a field course about SLUS. So what is SLUS? We're going to see more about that. So after we develop curriculum, we offer Master of Science in SLUS since 2002, approximately 22 years already. This is a 2-year program, and we have 2 study plans. The first one is just thesis only, that may be good for a foreigner student or who have experience. And the second is the thesis plus coursework. So we have now almost alumni, more than 190 people that are working in many sectors, both in government and private sector in Thailand and also abroad. Also, after that, we develop and offer PhD in SLUS since 2006. It's about 18 years. We have just offered 3 years program for that. The study plan almost the same of master degree, and we have alumni more than 53 people. So for this program, we have also international students. I mentioned before that our alumni is also from other countries. And actually, the student can get support from Tiger and Siaga scholarship. Just since last year, that German and Siaga scholarship started to grant for master and PhD scholarship to SLUS program, particularly at KU. Now today, as I mentioned before, we have consortium, many university and sector in Thailand, but for now, we are so proud to say that we just only one in Thailand that's still offering for SLUS program. And also can say that just only one in the world, because in Denmark, they also stopped for the program SLUS. In South Africa and in Malaysia already stopped. So we are sustainable, offering the degree, just the same as the concept that we would like to be, sustainability. So, and we hope that we're going to continue more for our program and hope that we can get more partner and consortium from Japan, Korea, and other universities. So the aim of this program would like to, train the graduate student to have abilities to analyze, synthesize, and evaluate crucial problem and issue related to land use and natural resource. With 3 approach, this is very important concept that we developed together with Denmark, South Africa, Malaysia, and other partners, that we agree together that if we would like to have sustainability or have sustainable management, we have to apply 3 approaches. First, problem-oriented. Second, interdisciplinary. And third one is participatory. So we hope that the students, they have their own background from bachelor study. And after that, they can add up other perspective that they don't have in SLUS. So for example, students come from science-based. They can have like social or economic perspective to help for better working for their research. So for the participatory, we think that it is very difficult if we would like to deliver our research finding or our technology to user. So if we have the beginning of participatory from stakeholder, since in the beginning of research, then when we transfer the technology or research finding, will help us to better achievement to deliver this technology to the user. So, and the other one is very important, is interdisciplinary. So, as you know, that natural resources management and land use, that's very complex issue. And it cannot be coped with just only one discipline. In reality, we need to work together with many or multidisciplinary people or multidisciplinary knowledge. So that's why the SLUS student will be trained in interdisciplinary perspective. So because we are interdisciplinary program, of course, we are undergraduate school. We just only one of 3 interdisciplinary program under KU graduate school. And for our participation, for many sector in KU that involving 6 faculties: agriculture at Bang Khen, agriculture at Kampeng San campus, faculty of forestry, faculty of science, economic, social science, and environment. So we can say that we are truly interdisciplinary program, that we work together not just only interdisciplinary knowledge, but also interdisciplinary group of people. So how we work? If we have our student, we have working committee as I'm a chairman, and we have administrative committee that we can consult for policy making. And also we will running the program based on the standard of graduate school. We work together with faculty from many faculties, right, interdisciplinary. We have advisory for the student that actually we recommend students to choose the advisor committee from different fields. For example, one may come from science-based, one should come from social science-based or economic-based to help them to, integrate the knowledge in terms of natural resources and socio-economic. And we also have administrative staff to support for that. So we offer many courses, both in PhD and master degree. So I will not read it here, but it covers tools, as I say, tools and techniques from science-based, socio-economic based. So students have to learn both views, and then they apply these tools and techniques that they learn for their research. The highlight of our program is the interdisciplinary field study. This is continue from the first of joint field course with our international consortium. So actually before COVID-19, we still have joint interdisciplinary field study with Danish students and also other international students. But since then, it stopped. So we just would like to recall again for international students to join us for joint field course or interdisciplinary study. So what is it? I will just talk next. So this is just a normal teaching standard that we have. We have both on-site and online. We have different style of teaching, have group working, sightseeing, practicing, that to make sure that our students have both knowledge and skill. So every subject, most of them, we try to organize field trip for students to be close to the nature, to know the real natural resources and the problem, what's going on. And what I'm saying about interdisciplinary field study, that before we have joint field course with international students, and I would like to promote. Now, SLUT would like to recall this back to have joint interdisciplinary field study. We will assign students to the area base. We will choose some area base for students and let them try to apply their knowledge that they learn and use tool and technique to find the problem, identify the problem in the area related to land use and natural resource. And after that, they try to formulate the proposal, like research proposal or suggestion to the area how to solve with that problem in land use and natural resources. So at least students will stay in the area about at least 2 weeks and work together. Actually, we prefer to have interdisciplinary student background. So we would like to have like mixed students from social, from economic, from science, from forestry, from agriculture. Because as I say, to solve the problem in land use and natural resources, we require interdisciplinary work. So if students come with different background and work together, then we will be successful for interdisciplinary field study. And this experience, the reflection from our students said that that's very good experience for them and can be useful in their real life. So from that concept, our thesis research for SLUT students is very diverse and like interdisciplinary topics. Of course, nowadays there are many hot issues, particularly climate change or like technology interruption, AI, whatever. So actually can be applied for SLUT research. And I can say that even the concept of problem-oriented, interdisciplinary, and participatory approach has been set up since 20 years ago. But nowadays, we still talking about sustainability. We have not reached sustainability yet. I remember that Sustainable Development Goals set up long times ago and would like to meet the mission like since many years, but it still extend and extend. So what's going on? This is very challenge for us to, to whatever the research that we are interested, so we can use SLUS concept to make us to reach achievement in sustainable in different field. So just the, abbreviation and just a short introduction for SLUS. So just would like to say that welcome to join us at SLUS. So we offer both Thai and English. And also, as I mentioned, we would like to have more international students, particularly for international joint field course, at least 2 weeks. We try to work with other partners who will help to grant students to have opportunity to join the joint field work. So this is the weekend study. So who have been working, still have study and work together. And yeah, of course, one thing that I found reflection from our students, now they are high position. When they come to us at the beginning, so they respect us. But now I have to respect our alumni because they are like nearly minister of some ministry in Thailand. And also some fresh graduate students, they have a good network from that people who come from many sectors to study. They have a connection. And after that, after graduate, they also have a good opportunity to get a job, both in government organization and also got a job in private sector and consultant company. So just if everyone interested more about SLUS, please contact us with the email here, or we also have Facebook, and also we have a website. Please visit us, and also please welcome to contact graduate school for more information, and also myself. So thank you very much.
Okay. Thank you very much, Professor, for welcome speech. Okay, and then the next sequence we will follow is the keynote address on the topic as introduction, Professor Wu Zhou Laboratory, which is presented by Assistant Professor Dr. Wu Zhou from Guangzhou National University. Please, sir.
Good morning, everyone. I'd like to express my sincere gratitude to KU for the warm invitation. Actually, I'm not prepared for all content of my laboratory, but I'd like to introduce my laboratory's progress for sustainable agriculture. So my lab name is Agricultural Intelligent Control. Specifically, my intelligent agricultural control is targeted to set up of strategies and systems for efficient resource utilization. Content is shown as below. So first, my lab member is very small. Besides me, there is one PhD student, one master student, and one bachelor's degree student. My target is first considering what is the current limitations or problems in agriculture. As displayed here, there are lots of population growth is expected in our future. However, to support all of the population, the water is very lack of supporting all members. In addition, the severe changing climate or less available land or water makes this problem more difficult to solve. So my answer is focusing on hydroponics. As you know, hydroponics is widely used for the up-to-date smart farming facilities, such as plant factories, smart greenhouses, or even in aquaponic systems. And for the efficient hydroponic systems, I'd like suggest some improved solution for the fertigation management. So, two most important issues in fertigation management are nutrient solution management and fertigation scheduling. As the first step, I tried to set up an undergo crop monitoring system for estimating the crop water need. As you know, the crop water need is varied according to their growth or the growing environment. And one of the most important factors is related to their growth. So I try to measure their LAI, that means leaf area index, by using the undergo monitoring system. Also, I measure the radiation and the temperature and relative humidity to estimate their real-time water need based on their transpiration rate. This is the progress line of my developed image monitoring system. According to the preset schedules, this automated image monitoring system captured the images of growing lettuces inside the plant factories. I just use a simple algorithm to measure their leaf area index. Based on the excess screen conversion and also threshold method, I calculate their leaf area index from the pictures. And then, based on the modified Pema-Montes model, I used this value to estimate the real-time transpiration rate. To compare the model performance with the actual transpiration rate, I measure the real transpiration rate based on this water weight balance model. It shows the results of the automated monitoring systems. Based on the monitoring systems, I can monitor the growth pattern of the lettuces in the plant factories. Also, I can measure their distribution map of canopy cover and then evaluate their vegetation indexes inside the growing bed. Although there was some poor estimation happened at the late growth stage, however, in this season, we usually harvest the lettuces, so I think it's not an important problem. So based on this model, I just estimate the transpiration rate, and it shows a quite good performance compared to the actual transpiration rate. As the next stage, I'm focused on the nutrient solutions components. Nutrient solutions should supply some essential nutrients for crops. However, the current technologies based on the electrical conductivity or pH cannot provide the nutrient individual ions. So I think the ion sensors would be necessary to control the nutrient solutions balance. So my choice is use of the ion selective sensors, and also I develop an own algorithm for calculating the well-balanced nutrient solutions. Actually, several studies use the simplex matrix to calculate the ionic balance in the nutrient solutions. However, it has a possibility of the negative solutions for the given concentrations of nutrient solutions. So, based on the priority of the nutrient ions, according to the previous studies, I set some priority levels and select some individual nutrient salts to efficiently manage the recycled nutrient solutions. This is the decision tree-based dosing algorithm I have developed to manage the recycled nutrient solutions. So I integrated these two systems as one and then evaluate their performance to grow performance of growing lettuces. I skip this slide. So after the measurement, the system shows more well-balanced nutrient solutions compared to the conventional algorithms. So I think this algorithm can provide more balanced nutrient solutions even after the recycling of the nutrient solutions. Specifically, the nitrate, potassium, and calcium, which are measured by the ion sensors, these three ions showed more superior balance compared to the conventional systems. Based on the result, I conclude that this system can reduce the overuse of the fertilizers in hydroponics. Now, one of the focusing area is the real-time root phenotypic analysis for advanced water supply. Actually, my first research is try to measure the crop activity based on their vegetative growth in the upper side. However, the water and nutrient absorption are actually happened at the downside of the plant. So my approach is to develop a phenotyping system for the crop root. I use the LiDAR sensors, which can measure the 3D information of the object. And I just adapt these sensors to the growing bed of the downside. As you know, nutrient film techniques or deep flow techniques may induce some flows of nutrient solutions in the vision area. So I choose the growing bed as aeroponic systems. So based on the LiDAR sensors, I can observe the real-time root growth and even measure their 3D volume indices based on the depth images. To compare the model performance, I tried to measure their more accurate volume indices based on the commercial sensors. Although some noises are happened, so it makes deteriorated quality of root images. However, I think it would be available for use after the model improvement. The next step, I try to measure the growth environment in the root area. Actually, the aeroponics is very innovating hydroponic approach because it showed more improved water and nutrient use efficiencies compared to the conventional hydroponic techniques. So I want to measure the environmental changes in the aeroponic bed, and I choose the WIMOS board, which can measure the relative humidity and temperature inside the aeroponic bed. Since the SHT31 sensors is waterproof, so I think these sensors can be used to measure their environment. To evaluate the sensor's performance, I just randomized their positions inside the root zone area. And the result shows several spatial variations are displayed, but the sensors can be used to measure the variations in the aeroponic environment. Although several noises happened in the initial stage, however, I can reduce the noises by adopting some air conditioning systems. Now, I try to improve my current researches by using more advanced crop monitoring systems and AI algorithms. Specifically, I also want to develop more versatile chemical sensors that can measure the important ion types of magnesium and phosphate inside the nutrient solutions. Based on these improvements, I think our laboratory can achieve more improved various kinds of solid culture methods, and also I can reduce the water and nutrient use in hydroponics by achieving more adaptive and variable dosing algorithms and fertigation algorithms. Thank you for listening to my presentation.
Okay, thank you very much, Professor, for your speech. Okay, now the next, we will be going a short break for you to enjoy this statement and participant also. We will give a break period 10 minutes. And going on at room, approximately 55 past 9, yes. We will start the seminar at the 10 o'clock. Yes. Okay. Okay. If any who presentation who do not yet deliver the file on the stage, please can they do that? Yes, sir. Okay. We can inform honorable guests to make the evaluation from academic to QR codes in the mornings, please, sir.
Sorry.
What's your name?
My name is Unique. Unique Chan.
아니 여기 노트북 그 키보드 위에다 올려놔도 괜찮아.
태블릿 다
Can I use this? Thank you. This. Okay.
What's your name?
My name is. Here.
Okay.
Are you student? Are you student? 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 Master?
You, I, master.
Master, master. Same, same. Okay, no.
Finish.
Okay, thank you.
What's your name? 이거 맛있어요. And this is just one. And Jacob Sabji Tax. This is Tax.
ช็อตเบรกจะเบรกเวลา
แบบไม่ใช่แบบเขาพูดคือมันหมดเวลาแล้วอะเขายังพูดไม่จบ
ก็ไม่แน่ใจ เดี๋ยวคำมันจะไม่นี่นะก็เป็น
น่าจะบอกให้แบบเขา
จะบอกประมาณว่า
ให้สรุปภายใน30
โอเคก็บอก you have to conclusion your presentation on time
อะไรyou
ก็เป็น you should you have to conclusion your presentation on time
โอเค
แล้วเรากดออดครับว่าน่าจะโอเคแล้วอ๋อยังมีไม่มาลงข้อมูลอีก4 คนต้องไอช่วงเบรก2อาจจะต้องแจ้งเขาอีกรอบหนึ่งว่าให้มาลงข้อมูลมี4 คนพี่ก็บอกช่วงเบรก2climate smart solution ไม่แน่ใจประเทศอะไรน่าจะญี่ปุ่นวันนี้น่าจะญี่ปุ่นแหละพี่ไม่แน่ใจครับ
เกาหลีครับ
น่ใจว่าคนไหนอยากจะไม่บอกแจ้งเราอีกรอบหนึ่ง Okay, the next sequence will be coming Samana. For today, there are 4 topics concerning various academic topics in the theme of smart faculty, agriculture, and water management in the climate change year. The first topic is smart technology in faculty and agriculture by present for this section. The next we will would to pass this set on to Mr. Pong Siri to continue the program. No. เดี๋ยวให้
Good morning, everyone. My name is Pong Siri Phasi, and I will serve as the chairman and the timekeeper for the first presentation section. The presenter for this session are Thammalaka Nilas, Pangjin, Juthamat, Sri Konglak, Okundele Oluwasekun, and Nakamura Alisa. To ensure that everyone use their time effectively and stay on schedule, each presenter will have 12 minutes, including both the presentation and the question and answer section. When there are 3 minutes remaining, I will ring the bell once to notify to presenter. When the time is up, I will ring the bell twice to indicate the end of the presentation. Okay. First presenter, Thammalaka Nilas. Okay.
From the stage? Okay, thank you. Good morning, everybody. And I would like to, first of all, present my gratitude to all professors from all the university. And it is my pleasure to present my research work in this platform, International Joint Seminar 2024, organized in Kasasat University, Thailand. And the topics of my research is ripeness level and picking point detection of strawberry using depth fused Marx RCNN acquired by molecular depth estimations. So I would like to go to the content. So getting to the introductions, basically strawberry harvesting is the process of picking ripe strawberry. And traditionally it is done by the manual labor. And it is labor intensive. Therefore, the agriculture suffers the labor shortage, and the cost of labor is also increasing. Because of that, the agricultural productions have moved to the automatic harvesting robots. And in case of automatic harvesting robots, there are basically 3 components: vision, navigation, and control. And in this study, I'm trying to solve the challenges regarding the vision system in strawberry harvesting. So talking about the strawberry harvesting challenges, strawberries are delicate fruits. So they need to be handled with care. And basically while harvesting, they are harvested by grafting and cutting the potentials. But talking about the potentials of the strawberry, The petencials are very thin structures, and in the dense fluctuations and unstructured environment, they are very difficult to locate, detect, and identify. So this is a major challenge, and therefore, in current studies, basically strawberry ripeness level is detected, and ripe strawberry are detected, identified, and the shape of the strawberry are find out. For detecting the potentials, the potential is estimated on the basis of the shape of the strawberry. So in this research, what I'm trying to do is I'm trying to find out directly the identifications and detections of potential so that we don't have to calculate the locations of the potentials. But the problem regarding this is the traditional depth estimations sensors that are available, they are not so accurate. So my hypothesis regarding solving this problem is to find the depth information using the state-of-the-art this molecular depth estimators and fuse that depth information with the RGB image to enhance the detections, identifications, and segmentations process. So basic objective of this study is to create the data sets and generate the depth informations using GeoDepth molecular depth estimator, then develop a model that is customized Max RCNN, in which we will be fusing the depth, and finally we will be finding out the depth of the potentials using the coarse depth. So moving toward the material and method, this is the system flow diagram regarding the picking point detections of ripened strawberry. So it consists of four parts. First part is the acquisitions of RGB image and depth image using LIDAR RealSense L515, and then the RGB image has a coarse depth obtained from the LiDAR. So for having dense depth, we will be using molecular depth estimators. Then this dense depth information is mixed with the RGB image in the modified Max RCNN called depth fused Max RCNN, which will enhance the segmentations, detections, and identification process. Then we will obtain a marks of potentials and ripe strawberry, which will be further on used to mix with the depth information obtained from the LiDAR. Then the proper accurate and precise depth is calculated. For this, the experiment is carried out in the Smart Space Sensing Laboratory greenhouse, Jinju, Gyeongsang-namdo, South Korea, and the strawberry grown was, the cultivar is Shoalhang, and it is cultivated in a bench-type configurations with 5 rows, and the period of image instantaneous taken was from early December 2023 to February 2024. And the image was acquired using LiDAR camera L515. And with the help of that acquired image, we make a data set, 2 data set. One is BBCH 85 and another is BBCH 89. The acquired images were labeled for the different strawberry maturity and associate potentials, and the annotations was done using polygon annotations, and the software used was Level Studio. So required annotations done is shown in the table. And this is the complete schematic diagram regarding the process. As I shown in the flow diagram, the RGB image and the depth image are acquired, and the RGB image is go through the molecular depth estimator models where dense depth map is generated, and this dense depth map is mixed with the RGB to create the depth fused image. Then it is applied to the Max RCNN backbone. Basically, backbone we used were resonate 50 FPN and resonate 101 FPN. Then the strawberry were classified using the Mach RCNN into the mature, immatures, and transient, and associate potentials were detected. Then those detected potentials depth is find out using the depth estimations of segmented objects, and the picking point is localized. And to measure the model performance regarding the modified depth fused Mach RCNN and the standard Mach RCNN, we use standard model performance, precision recall, F1 score, and mean average precision. Similarly, to find out the depth estimations, RMSE and MAE is used. Now moving toward the result sections, as I suggested, we have created a depth fused Mach RCNN having 2 backbone, and Mach RCNN, baseline Mach RCNN having 2 backbone. According to the model performance, we can see that the depth fused Mach RCNN with resonate 101 FPN outperform all the models. Like we can see F1 score is 92.40%, and MAP at the rate 0.5 is 99.30%. Basically, in case of model performance, we check box model performance and instant segment model performance. So in case of box performance, it is 99.30, whereas in case of instant segmentations, F1 score is 89.84% and MAP is 98.10%. Similarly, in case of class-wise bounding box performance and class-wise instant segmentation performance, we can see like for each type of class, immature, mature, transient, and potentials, the model, in case of previous studies, we can find that it is difficult to find the transient model. But in case of this model, it has outperformed the transient classifications. This can be seen over here. And we can see like in inference, what is the response? This is the Mach RCNN response. Here, the potential is not properly detected. In case of depth fused Mach RCNN, it is able to correctly find out the potentials. And similarly, in these pictures, the potential is partially detected. When there is a leaf occlusions, it is unable to detect properly. But in case of depth fused Mach RCNN, since there is a depth information, it is able to correctly find out the potentials. Similarly, in case of depth estimations, when we do the 300 samples depth measurements with respect to the ground truth, mean absolute error was 1.98 centimeters and RMSE was 2.13 centimeters. So moving toward the conclusions, talking about the research probe developed a comprehensive data set featuring strawberry at various ripeness level, along with segmented marks for fruit and potentials, and utilize GeoDepth molecular depth estimations to find out the dense depth map. And we constructed the depth fused Mach RCNN, which take an advantage of depth informations, spatial informations of the object in the scene to improve the enhancements, and depth estimations accuracy regarding the MAE and RMSE is 1.98 centimeters and 2.13 centimeters. But the Mach RCNN we use in this research is required heavy computations. So the real-time operations has been compromised in this research. So in future works, I will be optimizing the model performance so that it can be used in the real-time sense. So this is the results. So I would like to thank you for listening. If there are any queries, then I will try to address it. Thank you.
Thank to Thamalaka for presentation. Next, invite the next presenter, Pang Jin. หมดเวลา
Yeah, hi. Actually, I have some memo under this, so I want to say can use. I want so memo under this. Want to give the speech. I want to see my memory under the picture when I give the speech, but if you use like this, I can't say my notes. Maybe change it. Okay, maybe I can use I can set my PC here and give a switch with this PC so I can see both of them. Okay. Okay. Hello everyone. Today I will give us about my research is the adhesion strength between the surface of the base material coated with selective base impregnating material and the inorganic coating method. So before I start my speech, I want to ask how many people are learning about the convincing facilities in here. Is anyone, if anyone is learning about it, you can raise up your hand. Okay, so it's never mind if you are not learning about this. So do you know how to repair water conservation facilities? Anyone? If you know, you can give up your, raise up your hand. No? Nobody know how to repair it? Okay, never mind. Maybe you know how to speak in your language, don't know how to speak in English. It's the same with me before I prepare with this speech. So in Japan, there is the main way to repair the water facilities is surface impregation method and surface coating method and cracking auxiliary method and so on. So today my speech is first is about the surface coating method, and in one of it is the inorganic surface coating method. You can see in the picture, they put the mortar into the concrete to repair the place where has broken. So the surface coating method is a method of covering concrete to the block determination factors and such as moisture and oxygen and salty that blend into the interior of the concrete from the surface. Thereby, it will prevent concrete from spalling. So the inorganic surface coating method is one way to use the inorganic materials. This kind of materials are highly derived from the rain and sunlight. So inorganic coating methods are very suitable for the open channel. So another way to repair the concrete is the selective-based surface imbrication method. As shown in the picture, when we apply the imbrication, we apply the impregant material on the surface of the concrete. It will have a chemistry reaction with calcium co-oxidation or high oxidation. So it will formation of the CSH gel to fill up the cave of the surface on the concrete. So the concrete will be repaired and in a short, in not very long time, and the merit of the material it is very green to the environment. So today in my research we combined with these two methods together. First of all, we used the selected-based surface imbrication method on the surface of the concrete, and after that we will use the inorganic surface coating method. And all of last, we will selective-based surface imbrication method do selective-based surface imbrication method again. So what will make it different from the other construction method? And the selective-based surface imbrication method, he can repair the surface of the concrete. So after that, if we coating the concrete, it can be kept for a long time from the other broken way. And after that, and coating after the coating method again, and why we do the select-based surface improvement method, it's to improve the quality of the organic surface coating. So my purpose of my research is because we combined with these two methods, it have some problem, like the how about we used the imbrication material? About his adhesion performance will be bad or be good. Also, the application of the treatment method the construction method is that good for this kind of construction. So this is the two purposes of my research. So the next picture about my experience, the test board in the picture is what I use. And the standard conditions for 15 pieces and cold heat cycle test for 10 pieces. The standard conditions is to test the basic adhesion strength, and the cold and heat cycle test is to confirm if this construction can be used in a cold environment. And the table in the slide shows the coating materials we used in my experiment. And this is the two combination of my research. So the step of the experiment is first to clean up the surface of the test board, and then coating with the impregnating material. And the most important to say is the 18 hours. 18 hours is set up for the curing. So after that, we will clean up the surface again to remove the impregnating material to reduce its influence to the inorganic coating material. And after we clean up the surface, the coating material will be applied, and then we will take 28 days curing. So after that, we will conducting the adhesion test. So next picture shows the results of the first standard conditions. You can see the reference value. All of my data is above the reference value. So it shows the adhesion strength is good, but you can see the 201 gram milliliters. You can saw it there. It's under the reference value, so I need to know why it's under the value. So from the advice from my professor, it says maybe there is a possibility that impregnating materials remains. So I do another retest. So I changed the curing time at the first time to use only 90 minutes. After 90 minutes, we will clean the surface and do inorganic coating method. After we do that, we can show the result. The green one, it's over the value we set up for 1.5. So this is another result for the heat and cold test, circle test. All of the value, all of the value are above the reference value. It means the all adhesion strengths meet the standards. So about the summary, both standards and hot-cold conditions meet the standard values, but if the impregnating material remains, it will be a problem of the concrete repair method. So for that, maybe we should, as I show you in the method picture, we need reduce the curing times, because if we set the curing time for 18 hours, the impregnating material will become hard. It will be difficult to remove. So the short curing time can be easier to remove the impregnating material. So in the future, it is also at this experiment only test about the Haitian strains. So in the future, it is necessary to confirm the application of depending on the degree deterioration of the concrete surface and verify the durability of the effect. Thank you, that's all.
Thank to Hang Jin. Next. Invite the next presenter, จุฑามาศ ศรีคงลักษณ์ครับ
Good morning, everyone. My name is Juthama Sikonglak. I'm from Department of Forest Management, Faculty of Forestry, Kochi University. Today, I will discuss my research titled Application of Machine Learning for Land Use Classification using Landsat 9 data in Eastern Economic Corridor, Thailand. The thesis outline is have 4 steps. 1. Introduction to study area. 3. Material and method. 4. Result. 5. Discussion. And 6. Conclusion. In introduction, this research is focused on remote sensing is optical remote sensing has used classified by visual interpretation and digital analysis. In digital analysis have two types. It has supervised classification and unsupervised classification. Another one have machine learning for classification. In my research, it has 4 algorithms for machine learning. It's about random forest, k-enable, support vector machine, and Gaussian mixture model. The last one is land use. The land use form land development department. It have 5 cards for classify. 1 for forest land and 2 water body. 3 agricultural land and 4 urban and built up land. The last one is miscellaneous land. This research focused on utilizing advanced classification techniques such as machine learning, include random forest, support vector machine, k-enable, and Gaussian mixture model, and analyze land use. Additionally, I compare this method with traditional visual interpretation techniques to evaluate their accuracy and reliability. The result aim to provide insight for land management and sustainable development in the Eastern Economic Corridor area. The study area is the Eastern Economic Corridor have 3 provinces at the east part of Thailand, include Chachoengsao Province, Chonburi Province, and Rayong Province. Our study focused on the Eastern Economic Corridor in Thailand, which spans approximately 1300 square kilometer. Material for my research have two steps. One step is classify land use it for material. One, land use image data. Two, Eastern Economic Corridor in GIS. Three, QGIS version 3.28 and 4 computer. Another one step is the ground check for Eastern Economic Corridor. Have three material about GPS, toilet sheet, and digital camera. The method have 4 steps. First step is pre-processing. The pre-processing is atmospheric collection using the Highland equation and select of preset terrain collected image covering the Eastern Economic Corridor region. Second step is classification. When do you want to classification? You have training area for training classify land use. And another one, you have, I have 3 classification about one visual interpretation and automatic have for supervised classification and machine learning about 4 algorithm. The first one is random forest, support vector machine, and classification K-relatable and Gaussian meter model. After you classification from automatic classification, I have filtering technique for repeat different pixel with the same value as surrounding pixel. Third step is accuracy assessment. Accuracy assessment was measured using the error metric, overall accuracy percentage, and kappa statistic to evaluate the performance of each classification method. The last step is GIS overlay and analysis in QGIS version. This compare different of each land use classification result. The classification result revealed of following. Visual interpretation achieved the highest accuracy as 97.3%, followed by support vector machine. Followed by support vector machine has 81.08%, and random forest has 67.57%. The K-reliable and Gaussian meter model has similar accuracy level of 62.16%. This graph for overlay land use classification, the total of support vector machine has highest area similar visual interpretation. Discussion. Our finding align with previous study such as taught by Nanoy, which highlight the effectiveness of support vector machine for land classification. However, difference were observed when comparing the study like Talakta 2020, where random forest prefer better in other region. Moreover, the extensive agricultural area in Eastern Economic Corridor highlight the need to fill validation to enhance classification accuracy and monitor filter land use change effectively. In conclusion, this study demonstrates the potential of machine learning for land use classification using Landsat 9 data. The visual interpretation method achieved the highest overall accuracy assessment, but support vector machine show substantial accuracy assessment indication. The indication is reliability as a automate alternative. This research provide valuable insight into land use pattern in the Eastern Economic Corridor and offer practical application for future land management state. Thank you for your attention.
Thank to Juthamath Sikhonglak for presentation. Invite the next presenter, Ogudele Oluwasegun.
Okay, good morning, everyone. Firstly, I would like to thank all the professors and organizers, as well as all participants for this opportunity and platform. My name is Ogundele Oluwasegun Moses. I'm a master's student at the Department of Biosystems Engineering at Gyeongsang National University in the Smart Space Sensing Laboratory under the supervision of respected Professor Hyun Tae Kim. And I'll be presenting my research titled Analysis and Optimization of a Single-Span Naturally Ventilated Greenhouse Using Computational Fluid Dynamics. Now, the basic content is as follows: introduction, materials and methods, results and discussion, and conclusion. Recently, protected agriculture through the use of greenhouses has been gaining a lot of traction worldwide, and this is as a result of many factors. One being that protected agriculture through greenhouses provides increase in yield per unit available land area, And furthermore, when you use greenhouses to grow crops, you are able to optimize factors such as temperature, relative humidity, light, and using greenhouses, you can also better control factors such as your efficient water management, as well as protect the crops from pests and diseases, and better inputs such as fertilizers. Then this use of protected agriculture through greenhouses recently has also been a crop protection tool. Like the theme of this conference, this joint seminar, is one of the key aspects is climate change. So with the increase in drastic weather patterns worldwide, farmers and producers are no longer able to accurately say that this is the right this weather or this weather pattern in a particular season is going to be suitable for growing crops. So with all these issues, this is one of the reasons why there's an increase in trend of the use of protected agriculture, particularly greenhouses. Others include screen houses, plant factories, etc. So now moving on, the use of greenhouses is not without its challenges. One of the challenges being that it is very difficult to control the microclimates in the greenhouse. That's your temperature, your relative humidity, CO2, and sunlight. So although we have automated systems which can better control these factors, but these systems come at a very high installation cost. So many regions in Asia, South Korea being one of them, prefer to use naturally ventilated greenhouse structures, otherwise known as passive ventilation structures, to grow these crops. So with using these passive greenhouses to grow crops, these naturally ventilated greenhouses are dependent on a lot of factors, such as the height of the greenhouse, the weather conditions, the outside weather conditions, the geometry of the greenhouse, as well as other factors. So now in order to solve this problem, I am proposing the use of computational fluid dynamics as a tool a powerful and cost-effective tool to control and optimize greenhouse design and environmental control. CFD enables detailed analysis of complex airflow patterns within the greenhouse, providing insights into the effects of various environmental factors. With the use of computational fluid dynamics, you can consider a lot of unbuilt scenarios where specific to a location, for example, South Korea or here in Thailand, you can make use of the CFD tool in order to simulate the microclimate for a specific region without having to build the structure. So moving on to the objectives and significance of this study, I want to develop a computational fluid dynamics model for simulating the microclimate distribution within a single-span greenhouse, and verify the accuracy of this CFD model by comparing the prediction with experimental measurements, and assess the capability of the CFD model in accurately predicting microclimate changes under various design conditions, thereby providing insights to optimal climate control strategies for enhancing crop yield and growth. And this research will be significant, being that it will aid in the better understanding of the thermal environment within the greenhouse, and furthermore, it will also, I hope it will increase the adoption of using CFD models in greenhouse design and planning. Now, moving on to the materials and methods section. These flowcharts basically explains the process. On the right-hand side, I have listed for the CFD simulation stages, we have the preprocessor, the solving, and the post-processor. So going through the flowchart, first we collect the data from the experimental greenhouse, and for the pre-processing stage, the computational domain in which the outside weather conditions will be defined is inputted into the model, as well as the boundary conditions. Then mesh generation is being carried out. Then for the solver stage, the CFD simulation is being run. And the criteria for testing, that is your convergence criteria, is being assessed. Then for the post-processing stage, the results of the model are being compared with the experimental measurements. This experiment was carried out at the experimental greenhouse located at the Smart Space Sensing Laboratory, Gyeongsang National University, in Jinju, South Korea. Regarding the specifications, it was a single-span, flat-arced greenhouse covered with a polyethylene covering material of 0.1 millimeters. And the sensor placement inside the greenhouse is illustrated in figure 3. Now, regarding the equipment, this temperature sensor, light sensor, and outside weather condition was collected from the Korean Meteorological Association. Inside temperature, we have temperature, relative humidity, CO2, and light. Then outside temperature, wind speed, and wind direction. The specifications of the sensors as well as the sampling time are illustrated in this table. So for CFD studies, where you consider the outside boundary conditions, you need to set the dimensions of the computational domain. So here in this figure, we can see the inlet, the outlet, and the symmetric condition, as well as the modeled experimental greenhouse. Then the dimensions of the computational domain were designed based on best practices and based on the minimum height of the structure. We can see that from the inlet to the outlet is a total of 15 times multiplied by the height of the structure, as well as from the end to the wall is both 5 multiplied by the height of the structure. Then furthermore, regarding the meshing, which involves the dividing the geometry into further discretized units, the unstructured mesh was used for this experiment, and with 220,000 nodes and about 1.8 million elements, and the quality metrics, orthogonal quality, skewness, and aspect ratio. So regarding the covering material, the air and the ground, the density, specific heat, thermal conductivity, absorption coefficient, scattering coefficient, refractive index, and emissivity, these were the material properties that were used for the simulation. Now moving on to the result and discussion section. These are the basic descriptive statistics that were collected for one day, that is June 16, 2024. And for insights purposes, recently when in South Korea, there was an increase in temperature, which could be attributed to climate change. So it was also discovered that the average temperature during this experimental data collection was higher than previous years, which should outline the basic problem statement that I said before. So these basic graphs here just show the temperature, relative humidity, CO2 concentration, as well as outdoor solar radiation. And from this graph, we can see that, as expected, the temperature and relative humidity are negatively correlated. So with regard to validation of the CFD model, there was a comparison between the experimental and simulated results, which showed strong agreement, and the observed differences between air temperature was 1.12 degrees Celsius. And these show some visualizations of the windward side and the air temperature and the air velocity within the single-span greenhouse. And you can see that the wind direction significantly impacts this air velocity and ventilation rates. And a recirculation loop near the roof slows air speeds and reducing air homogenization, while you can see beneath the greenhouse, they are expected higher temperatures. And the temperature distribution mirrors the air velocity profile, which I'll be showing in the next slide. So this is an unbuilt scenario. Unlike this, it shows a roof vent being added to the greenhouse. And we can see that there's a semi-spiral airflow with air still at the center of the greenhouse, and with regions with low air velocities, like where you have this 0.3 meter per second, there is a high internal temperature in those regions, and improved air mixing results in more uniform temperature distribution. So regarding to future studies, I plan on incorporating more unbuilt scenarios, such as an increase in the number of spans and possibility of adding a mix between roof vent and side ventilation. But so far, the conclusions of this study will be that the CFD model was developed to simulate the microclimate of the greenhouse and accurately predicts the dynamic temperature fields within the greenhouse, and validation was also performed. And the key finding shows that there's potential in measured air difference, air temperature, and accuracy and reliability. And this model can serve as a valuable tool for optimizing the performance of the greenhouse. And there is room for more studies. Thank you for listening.
Thank you, Okodele or Luwasekun. Next, invite the next presenter, Nakamura Alisa.
Hello everyone, I'm Alisa Nakamura from Kochi University. I will give a presentation on this topic. I will explain my research in this order. At first, introduction, next, overview of my research. Result 1, comparison of indicators of material permeability. Result 2, relationship between air permeability and air inflow. Finally, conclusion. Let's start with introduction, research background. Please look at picture on left. In concrete structures, these deterioration factors penetrate through surface layer, causing neutralization and soil damage. This causes the concrete to crack, cracking, and clog layer inside. To prevent this deterioration, surface layer of concrete and mortar need to have low material permeability. Non-destructive methods have begun to be used to evaluate material permeability. There are two methods for material permeability testing. One is Trento method, the other is cylinder method. However, there are few examples of their application to polymer cement mortar, and verification is insufficient. Therefore, purpose of this research is to clarify the relationship between air permeability and air inflow as an indicator of material permeability. Next, I will talk about overview of my research. The test compared two types of data that serve as indicators of material permeability and confirms the relationship. In Trento method, material permeability is evaluated by forcibly sucking air from inside to surface. Air permeability coefficient is KT, while cylinder method is a simple method for testing material permeability. In cylinder method, material permeability is evaluated based on the amount of air that flows into cylinder. The test was carried out in RC open canal in the field of Kochi University Monobe campus. Outline of the test area is as shown in table on this slide. repair using inorganic surface coatings and silicated-based surface impregnation method are expected to have the effect of suppressing cracks with expansion and filling cracks. Here, I will explain the result. There are one comparison indicators of material permeability. The left figure shows change in air permeability coefficient over time on the top, and the change in air inflow volume over time on the bottom. The result, both KT and air inflow volume are decreasing. The effect of filling the cracks was demonstrated. However, downward trend is different. Therefore, the real result of cylinder method or trend method do not necessarily correspond. I think reason for this difference is how to apply negative pressure. Regarding how to apply negative pressure, trend method uses a vacuum pump, while cylinder method simply fixes the piston. Pressure is different because the way negative pressure is applied is different. So, how to apply negative pressure may cause discrepancies in test results. Next, I will talk about result 2, relationship between air permeability and inflow. Since these results of cylinder method or trend method do not necessarily correspond, I confirmed correlation between these two data. Figure is a scatter plot with KT on the horizontal axis and air inflow volume on the vertical axis. The correlation coefficient between KT and air inflow volume at construction site in 2023 was 0.53, and correlation was confirmed. However, a correlation coefficient between them at the construction site in 2016 was 0.14, and no correlation was confirmed. Therefore, I think KT and air inflow volume no longer correspond after a certain period of time. Next, I confirmed the correlation for each material age at construction site in 2023, where the correlation was confirmed. The scatter plot is constructed as before, with KT on the horizontal axis and inflow volume on the vertical axis. Up to 5 months material age, the correlation coefficient was 0.151 and 0.47 and 0.73, respectively confirming a positive correlation. However, at material age of 6 months, the correlation coefficient 0.37, which means the correlation is weak. Therefore, through a follow-up survey, it is necessary to clarify whether there is a true positive correlation. I think the reason for weakening the relationship between KT and air inflow volume is difference in resolution. Resolution of trend method is 0.001 by 10 minus 16th power square meters, while the resolution of the cylinder method is 1 milliliter. It's big. The resolution of cylinder method is larger than the trend method. In concrete structures, due to aging, surface roughness of concrete and mortar deteriorates. Because of the large resolution, cylinder method, it's difficult to measure changes in air inflow. This can cause errors in the measurement results and the broad difference between KT and the air inflow volume. Finally, I will summarize this presentation. This study was conducted with purpose of clarifying the relationship between KT and air inflow as an indicator of material permeability. Through this research, I found the trend method and cylinder method do not necessarily correspond because methods of applying negative pressure are different. Also, there is a positive correlation between KT and air inflow volume up to a certain period of time. Therefore, I would like to clarify the boundaries of correlation between KT and air inflow volume based on material age. And in the period in which a correlation can be confirmed, I would like to devise an evaluation standard based on air inflow volume and based on KT. That's all. Thank you for listening.
Thank to Nakamura. Alisa, have time for. After this section, there will be a 10-minute break. For the second session, Mr. Kasidit will take over as the chairman. Thank you everyone for attention.
านมันจะเป็นพูดเลย
ใช่ครับพูดเลยครับ
ก็คือผมขึ้นมาตรงๆเลยหรือว่าต้องรอคนมานั่งก่อน
ก็น่าจะพูดได้เลยนะไม่มีอะไรแล้วครับก็กำหนดไปก็เบรกเสร็จก็พูดเสร็จก็
อีกประมาณนาที2 นาทีมันจะหมดเบรกแล้วผมพูดได้เลยว่าต้องรอคนมานั่งก่อน
นี่ถึงแล้วเหรอ17
มันถ้าตามจริงๆมันเริ่ม10แต่ว่าเมื่อกี้มันเลทมาประมาณ7-8 นาที
ก็อีกสัก2 นาทีก็เริ่มเลยก็ได้ครับ
พูดเลยใช่คนมันยังไม่นั่งผมพูดได้เลยใช่ไหม
เดี๋ยวถ้าเราเริ่มพูดผมว่าน่าจะเริ่มแล้ว
ผมพูดเลยนะครับพี่ครับพี่ครับพี่ครับGood morning. I am Katidit. I am study for master degree at Faculty of Forestry Year 1. Now I'm take on the role of chairman and timekeeper for the second section of the seminar titled Climate Smart Solution for Future Agriculture and Forestry. The seminar will process in the follow order of presenter สอนสวรรค์ชาติกลางยูชิดะริซาโกะมยองยงคังมัตสึยะทาคุมะแดยองคังชียองคัง and ฮารัมจิยอน The schedule for this session is as follow to ensure everyone utilize their time excellently according to the agenda. The following time regulation will be in place. Each presenter will have 12 minutes, including the time for question and answer. When there are 2 minutes remaining, a single bell will ring as a warning for the presenter. At the end of the allocated time, a double bell will ring to signal the conclusion of the presentation.
Good morning, everyone. My name is Sawachat and I'm a master student in Watershed Management and Environmental Program, Department of Conservation, Faculty of Forestry, Kochi University. Today, I am excited to present my research on investigating hydrological drought characteristics in northeastern Thailand under CIMIC 5 climate change scenario. First, I would like to tell you about my background of my research. Climate change significant influence extreme events, particularly droughts which have long-lasting impact on human life, the environment, and the economy. Hydrological droughts characterized by below average rainfall are critical for water resources management, especially as climate change alter weather pattern, increasing the needs for accurate drought prediction. However, predicting hydrological droughts is a challenge due to the non-stationary nature of hydrological process influenced by climate change, population growth, and human activity like land use change. The Simple Drought Index, or SDI, is a widely recognized method for assessing drought severity. Studies from another regions such as Northern Europe, Australia, and India demonstrate the growing intensity of droughts and the importance of mitigation strategy through like CIMIC 5 climate change model has ancient drought prediction, helping evaluate impact under variant climate change scenario. The Lamchengai watershed in northeastern Thailand, climate change has caused significant decrease in landfall and stream flow. It has severely affected agricultural, especially rice farming due to poor soil condition, change rainfall pattern during strong El Niño events. Rice product in Lamchengai watershed dropped by 24.52%. Is highlight to region vulnerability to climate variability and underscore to needs for sustainable water management. The study aimed to address the assessing research gap by evaluating the impacts of climate change on streamfall and hydrological drought in Lamchengai watershed using the streamfall drought index. We use the SWOT model to apply with downscale GCM projection under RCP 4.5 and RCP X.5 scenario, and then to analyze future condition in the next 5 years old in 20 and 29 and the next 50 years in 20 and 39. By integrating observed and project data, the research identifies drought characteristics. Now we move to equipment. We use data, climate information data, and daily streamfall information and climate change models such as ECR3, HM2, and MPI ESRMR. And next is SWOT model, and is another program such as QGIS, Studio, Comfy, and SuperGIS in my research. Method is the next step for collects for information. We collect daily rainfall data, daily average temperature, daily average wind speed, daily average solar radiation, and we collect from Thai Meteorological Department, and we get data from 1992 to 20 and 24. The next hydrological data, we collect the daily SIM4 data from Royal Irrigation Department, years of collect data from 2010 to 2021. And then next, we collect information physiogeography data, include dam, watershed boundary, streamline, soil type map, and land use map. Next, we move to data analysis. In my research, total have 3 steps for analysis. Step 1, we analyze the variation in the past and predicts future rainfall. And step 2, we use the future rainfall and swatch model for predicts future streamfall. And step 3, for assess in the past and the future of hydrological droughts in Lam Chiang Rai watershed. For in the future, we predict in the next 5 years and in the next 50 years. We also select assess climate change impacts after bias collection GCM outputs for evaluate agents baseline data to identify the best performance model. This model were then used to analyze SIM4 and drought index results under future scenario. This table 1 shows classification of hydrological droughts based on the SDI index. For my research, we use the trolley of land for the analysis drought characteristic, including drought event, drought duration, drought severity, and drought intensity. Now we move to the result. In my study was divided into 3 sections, and detail is following. Section 1, calibration and validation of swatch model. We use the Sufix2 algorithm in SWOT-CAP to ensure accuracy with statistic performance metrics showing R-square and NSE value above 0.75. And sensitive analysis identify 5 critical parameters, follow table 2. And the second part, identification of hydrological drought characteristic. Hydrological droughts in Lam Chiang Rai watershed were analyzed using SDI for 3 months and 6 months. In the figure 3, show SDI temporal variation with yellow to red representing increasing drought severity. For SDI3, frequent short-term droughts occur annually with serve event in 2040 to 2050. And for SDI6, middle-term droughts were less frequent but more severe and prolonged, particularly in 2015 and 2020. Follow the table 3, the historical drought characteristic in Lam Chiang Rai watershed represented by the SDI 3 and 6 months. This drought average 2.67 events per year for SDI 3 and SDI 6. This average 1.25 events per year. Both SDI-3 and SDI-6 highlight recurring serve and event droughts, emphasize the need for effective water management strategy. Maximum drought intensity is shown in DI2 and DIT. Were also identified show the region vulnerability to persistent drought condition is followed table 3. In the last part of results is about assessment of climate change impacts on hydrological droughts. And we found EC Earth has the most efficiency to predict my rainfall, future rainfall. And this is a result about future rainfall. In RCP 4.5, in the both of prediction had an increase of annual rainfall, but in RCP X.5 we found decrease the annual rainfall. This is the results about future rainfall is the similar form the future rainfall and increase in RCP 4.5 and decrease in RCP X.5. And it is a future hydrological drought characteristic in Lam Chiang watershed. In RCP X.5 have its drier conditions from January to April and improvement in the mid-year and decline at the year's end. And RCP X.5 have a worsening drought, particular severe from April to July is the both of year 2 prediction. This is analysis of SDI in different return period. In SDI 3 return periods in RCP X.5, severe droughts are most frequency, but in RCP X.5 is the most severe and widespread. But in the SDI-6 is in RCP X.5, severe drought are observed in 25 to 50 years, and in the short period in 0 to 5 years show not droughts. But in RCP X.5 is most intensive and severe droughts occur in 10 to 50 year returns periods with moderate drought severity cover most the watershed in 1 to 10 years periods. And conclusion, climate change have an impact in Lam Chiang watershed is show trend of future rainfall increase in RCP X.5 and decrease in RCP X.5. Thank you for your attention.
Thank you for your presentation. I invite Yoshida Risako to presentation.
Hi, I'm Risako Chida from Kochi University. Today, I'd like to talk about land-based actuation technology for viewers on Shadoshima Island and how it could contribute to revitalization local community. Here's how the presentation will go. First, I'll explain the background and objectives of the research. Then I'll walk use through the method, result, and discussion, and finally I'll wrap with future projects. In Thailand, there are dish called Hoi Rai Public Pao, and in Korea, there have actually done both future crabs. Yesterday, I had crab curry named Pupapong curry. It was delicious. The restaurant also have crab dishes on the menu which caught my attention. But honestly, they couldn't compete with the charm and flavor of the crabs. It also made me think I should switch my research focus from crabs to crabs. By the way, in Japan, clams and eggshell are commonly enjoyed in dishes like miso soup and sushi. However, over the past 50 years, where bears primarily live, Japan's tidal flat areas have decreased by about 40%, and factors like water quality degradation have led to decline in harvest. This highlights need for new accurate technology to boost domestic shellfish resource. My research site, Shoshima Island in Kagawa Prefecture, is located here in Japan. This island is well known across the country as island of olives. In recent years, it has been focusing not only on agriculture, but also food manufacturing, process industry, and tourism. However, Shodoshima faces significant challenge in a decreasing population and rapid aging society with fewer children. To address this issue, represents barriers in district and bring new energy to the region in essential. From my perspective, I want to present solutions through the lens of the fisheries industry. Shodoshima once had an abundance of clams, but due to the declination of their habitat, they have become nearly impossible to harvest. Several approaches have been attempted to tackle this situation. For example, one strategy improves swimming activity sand along the natural coastline to promote growth of clams. While this method showed promising results, it has not practiced because this sand was easily washed away the waves. The ultimate goal of this research is to represent local economy by developing various cultivation techniques on abundant farmland. With this in mind, we've started working on developing land-based agricultural technology for bears. Since Shodoshima has a lot of abundant farmland, replacing this land cut improves both crop yield and contributory to regional economic development. Our experiment consists of two plan parts. The first is an experiment to explore concepts for land-based bearers cultivation. Second is an experiment to test the possibility of growing bearers in abundant homeland in introduction seawater. Based on everything I've shared so far, I am focusing in concepts that actually considered for beavers cultivation. The two types of shellfish we are using in our experiments are the following. First is asari, which are the most popular type of clams in Japan. The second is akagai, which are larger than asari and are often eaten raw. So there is a likely high demand for domestic production of this species. First, we investigate how the presence or absence of sand and difference in density affects the growth rate of clams and arc-shell. For example, we compared the conditions with and without sand as well as with high density versus low density steppers. Here are the results of the clams that we've been cultivation for November last year to September this year. Growth was absent in clams under all conditions. We found that the presentation absent of sand, as well as distance conditions used in this experiment, didn't have a significant impact on their growth. Here is the result of the arc-shell clams that we cultivation from January to June. Similarly, we found that the presence of percent sand did not seem to affect their survival. Based on these findings, we can conduct that both clams and arc-shell can grow without sand. If sand is not necessary, it would significantly reduce the cost of land-based activity. Additionally, not using sand industry are new, more environment-friendly method of cultivation with low ecology impact. So far, I've talked about developing actuary methods in aquatic environments. Finally, I'll discuss the feasibility of new actuary methods using seawater in abundant farmland. Shōdoshima has many abundant farmland and fallow fields, and we are exploring the possibility of using this area for surface cultivation. We are also considering how to distribute harvest surface to local restaurants and souvenir shops, which could help differentiate the tourism industry. If these methods succeed, these could create a new industry model and contribute to regional development. This research demonstration to potential of sustainable agricultural technology using local resources. By innovation, not only local reservation, also younger generation and people from outside the region in this new industry. There's potential address difference and aging issue for creating new opportunities for jobs and actually fresh energy to economy. To depend my understanding of the region and connect it to my research. I am considering conduct interviews with local region and members of regional revitalization cooperation volunteer system to hear their thoughts on the fisheries industries and regional revitalization. I hope that our efforts on Shōdoshima can also contribute to solving national challenge. Thank you for listening.
The next step is to ask question.
Thank you for a very nice presentation. Your topic quite interesting, no? And I would like to know what kind of abandoned farmland in your research. What kind of abandoned farmland? For example, please give me the example of abandoned farmland. Farmland, you can explain?
So, we use vegetable abandoned farmland, no? Sorry.
Like abandoned farmland is mean no farmer.
Yes.
Yes, and cannot like prepare for the farm.
Yes.
Yes, and the question is, what kind of abandoned farmland?
Kind of.
Like a fish farm, fish, shrimp, something like that.
Don't. Um, uh, 海岸海岸線の近くってのファームラン
Time is up for asking question. Thank you for your presentation. And next, I invite Myong Yong Kang to presentation.
Good morning, everyone. My name is Myung Kang, and I'm from the department at Smart Farm at Gyeongsang National University. So it's great honor to be here and to present my research progress in this seminar. So now I'm start my presentation. So the title is Diagnosis of Strawberry Plants and Physiological Responses to Drought Stress using Chlorophyll 2 Fluorescence Analysis. So these are the contents. So first of all, I would like to explain about the chlorophyll fluorescence shortly. So first of all, this diagram shows the photosystem. So as you can see, this photosystem 2 and this is photosystem 1. So in this photosystem 2, actually the chlorophyll fluorescence is associated with this photosystem 2. So in photosystem 2, first of all, they can absorb the light energy, and from this H2O, they can get the electrons. So the electrons are transferred from this, actually this is called oxygen evolving complex. From here, they can transfer to the PS1. So at the time, they use the light energy, but during this process, some excess light energy is like emitted as the fluorescence. So if we can measure this fluorescence, then we can identify the state of the photosystem. So this is the short about the photosystem. So first of all, the drought stress is one of the most important environment factors, and which adversely affect growth, metabolism, and yield of crops worldwide. And photosynthesis is fundamental process which is significantly affected by drought. The long-term drought stress induces structure and functional recognition of photosystem. Therefore, the diagnosis model is required. So in these studies, there are two objectives. One is to determine the effect of drought stress on photosynthesis in strawberry plants. And another one is to identify the results of classification model based on the chlorophyll fluorescence parameters. So I used PCA to select some effective parameters, and I used the SVM model to establish the classification model. So this is the experimental materials. So I made three groups. One is the control and mild and severe stress. So all plants variety is the Seoryang, and actually Seoryang is the most famous, one of famous variety in Korea. So I used Seoryang, and this one is controlled, mild, and severe stress. I gave water for control is 200 milliliter per day, one plant, and mild is case I gave 100 milliliter water per day. Actually, this 200 milliliter is known as the standard watering for strawberry plants. And this is the all parameters that I used in this study. So basically, this is from FO to FM is the basic parameters. They can observe at in different time interval, and from these basic parameters, we can calculate some other parameters. We can call specific energy fluxes parameters. So you can see the like per RC or per CS something, and RC meaning is actually the relation center in photosystem 2. So like we can check about how much absorbed light energy and how much electrons is transferred and how much energy is dissipation using these parameters. And another one is the performance index. Actually, this performance index is just totally like the performance about the photosynthesis. So about the data analysis, I used the SPSS and using the ANOVA analysis. And I used the PCA model and SVM model. So this is the result of image in the changes under the drought stress. So as you can see, like actually first day after treatment there was no any difference, but from the second day after treatment we can find one curling leaf in severe stress, but there was no any changes in mild stress. But from the third day after treatment we can find also curling leaf in mild stress. And after treatment 6, the mild stress also has totally like curling. And this is the changes in soil moisture. So, and this is the result of the OJIP transients, like from FO to FM. So as you can see, actually this blue color line meaning is the severe stress. So at the time, you can see the overall blue lines is see the decrease about fluorescence intensity. So, but in early stage, actually this B graph this is the second day after treatment. At the time, like from O to I, you can see the little bit some increase the value of the fluorescence intensity. And this is the result of the chlorophyll fluorescence parameters. So you can see the like maybe actually in this depth 6, the DIO per CS and ABS per RC show the increased, very high increase compared to the control. And also like in mild stress also showed similar trends. And also you can see the decreased PI. PI meaning is performance index. So you can see it's like compared to control in mild stress and severe stress show the decrease. And about also in early stage, like in number 2 and number 3, show the like decrease in ETO about these parameters and increase in M0 and VJ. Actually, these two parameters is related with the closed RC and delayed QA reoxidation by QB. Actually, this closed RC meaning is they cannot get more electrons, so like they cannot do some for photosynthesis. And about QA meaning is the first acceptor in electrons in the RC. So actually related with these two meanings. And this is the result of the PCA. So I selected some of parameters. You can see the blue color box. So first of all, I checked about the PC1. And in the PC1, there is one, we can find some parameters and related with the PC1, correlation with PC1. So at the time, I selected some value parameters with value higher than 0.1. So using these parameters, I made one SVM model to classify this stress. So in the highest accuracy on the sixth day after treatment is accuracy was 96%. And in the second day after treatment, they showed 80% of accuracy. In discussion part, so actually I wanted to discuss about the drop of FM because until the second day after treatment, there was no any changes between the control, but after 3 days after treatment, they showed the decrease. But actually a little bit, sometimes like increased, but after 3 days after treatment, they showed the decrease. Because actually it is related with this energy dissipation. So actually it means when a plant use light less efficiently, the FM value can be decreased. And from O to I, show the first of all, like in second day after treatment, they showed a little bit increased, but after 3 days after treatment, they showed a decrease. The reason is that actually it is related with the stomatal conductance, because in mild stress, they the stomatal conductance ability can be high, so it is related with this stomatal conductance. And after few times, then like as you can see, the low stomatal factors were the main reason can be for the decline of the photosynthetic rate. So in conclusionly, in the early stage of water stress, changes can be observed in the parameters related to the oxygen evolving complex, which is directly affected by water availability and the associated with electron transport. So subsequently, it is determined that the plant use light energy less efficiently due to damage to the photosystem. And from the second day of the date, it was possible to classify the stress, but I think we need to like make more higher accuracy. So in conclusionly, like we need to find another parameters and about relate drought to stress, kind of like stomata conductance or report content. Then I think we can make more higher model with accuracy. So thank you for your kind attention.
If anyone have question, please ask for one question.
Thank you very much, Min Young, for your presentation. I have two questions actually. So the first one is, when you did your PCA analysis, which of the chlorophyll fluorescence parameters did you find affected the drought stress? Then the second question is related to how often did you collect the data? Like you have three groups. I think one is no stress, one is mild, one is drought stress. So how often did you, inoculate and collect data? Thank you.
No, just can you repeat one first question?
First one is the chlorophorescence parameters that during PCA analysis affected the drought stress.
Like what kind of parameters is affected to?
Yes.
So actually, when I do this PCA, I didn't explain about these things because maybe it takes some time. So actually, in second date, usually this from FO to FM parameters show the like for some high correlate with the PC1, and another like the parameters also related with some drought stress. So, but I think like you can see in both states, actually in the time they showed a little bit different like parameters, because I think actually what I said before was like in the second stage they usually affected by, I think, the stomatal conductance, but after 3 days after treatment they can get another the factor, I think.
Yes.
So yes, so that's why I think they showed some little bit different parameters, effective parameters.
Okay.
And the second one was how often collected, right? So I just collected one time in one day, and usually I collected nighttime. And maybe you can see this picture. So when I measure this chlorophyll fluorescence, you can see these 3 small leaves. So at the time I measure in the middle of the leaves, just one time.
Okay, thank you.
Thank you for your presentation. I invite to Matsuya Takumi to presentation.
Okay, hello everyone. I'm Takuma Matsuyama from Kochi University. I'm currently a fourth year student. Thank you. I'm currently a fourth year student in Kochi University. The contents of the research is to revitalize the region. I would like to proceed with the presentation in the following items. First of all, do you know a place called Kochi Prefecture in Japan? among the numbers 1 to 4, Kochi Prefecture is number 3. Shikoku is one of Japan's four main islands located to the south. Kochi Prefecture is situated in the southern part of Shikoku and is known for its beautiful nature and rich culture. The orange bird in the figure below in Kam City, Kochi Prefecture. The population of Kam City is about 24,760 people. Kam City is located in mountainous area and it is rich in nature, but the birth rate is decreasing and the population is aging. By the way, Kochi Prefecture is very famous for seafood, and I myself work part-time at a sushi restaurant, but I can't eat much seafood. Next, it's about the background. First of all, I would like to explain the Regional Revitalization Corporation's volunteer system. The Regional Revitalization Corporation volunteers are a system in which people who have moved from urban area to rural area work for a certain period of time to revitalize the region. The purpose of this system is to send new human resources to the region and revitalize the region suffering from depopulation and aging. The term of office is 3 or 4 years, and the reward is generally 2.4 million to 3.2 million yen. Next, I would like to explain the system of the Regional Revitalization Corporation Corps with a diagram. Once again, this system was created to solve the problems of depopulation and aging of rural area that Japan is facing. The purpose of this system is to invite people living in urban areas to rural areas and participate in activities to revitalize local communities. If you look at this figure, first of all, municipalities take the land in this system. And the municipality receives a budget from the national government and operates. Then, the person who becomes a volunteer applies to the municipality and gives a reward for the activities. At that time, we will work with the aim of further increasing migration with the aim of improving the attractiveness of the area starting from the volunteers. So, as shown in the figure on the right, the total number of employees in local governments is currently decreasing, and there is an issue of labor shortage. Therefore, we believe that we can play a role in supplementing the manpower of local government by utilizing the Regional Revitalization Corporation system. This figure is distribution map of the Regional Revitalization Corporation branches in Kochi Prefecture, Japan. The arrow on the left is my survey site, And as you can see, the number of members is small. In other words, there are municipalities in Kochi prefecture that are using this system and municipalities that are not. We aim to elucidate whether the cause is a problem with the system itself. The municipality and local residents and volunteers or other factors, and to obtain hints for regional development. Next, let's talk about the purpose. The purpose of this study is to focus on the utilization of the system in Kami City, especially in Kochi Prefecture, and to elucidate the factors. In addition, previous research has focused on the effect of the introduction of the Regional Revitalization Corporation's volunteer system and the current situation and issues of local governments that are utilizing the system. However, there are few studies that focus on this study, and I think that there is a lack of understanding of why some municipalities are not using it. Therefore, in this research, we aim to consider the factors and provide a new perspective for regional revitalization. Next, let's talk about the method. There are three main ways to do this. The first is interview. We will mainly use this method. The second, investigate indicator and date. From an economic perspective, we compare and analyze data such as population, change, and job certain. The third is a literature search. I would like to read and refer to paper related to this research. So lastly, this is the goal. In this study, we will consider the reason why Kami City is not using the system, and we hope to come up with ideas and measures on how to utilize this system in Kami City in the future. I would also like to think about whether the content discussed in this study can be applied to other areas in Kochi Prefecture. Thank you for listening.
Next step, please ask presenter for question.
Thank you, Mr. Matsuyama Takuma, for very good presentations and the very current issue regarding the regional revitalizations. Basically, in case of regional revitalizations, what aspects of regional revitalizations you are thinking of?
Sorry, one more question. Sorry.
Basically, you know, you were talking about the regional revitalizations, means like cultural revitalizations, or you want to do some crop revitalizations. What aspects you are, you know, trying to explore in this research work?
Okay. Um, uh, so, sorry, just a minute.
Okay, later on we'll discuss that.
Um, yeah.
Okay.
Sorry.
Thank you.
Thank you for your presentation, Masiya. Next, I invite to Dae Yong Kang to presentation.
Next time. Okay. Ah. Okay. Hello, I'm Dae Young Kang from the Gyeongsang National University. I am PhD candidate in the Gyeongsang National University. So now I would like to. This is not my file. I would like to present my research. The title is Analysis of Pig Tendencies to State Specific Sections within the pig band according to the environmental parameters and facility features. The content is following as the fourth step. So I would like to start the introduction. Firstly, we all know the pig band situation, like looks so dirty, and it's not depends some welfare for their life. So some researchers already conducted about the breeding system about the pig band and about the animal welfare. And they consider some parameters for improvement of the pig welfare. You can see the table, the biomarkers, and environmental parameters. Finally, ethological indicator like activity and behavior. In this study, I would like to understand the relationship between the environmental parameters and ethological indicators. So the environment, the physical factors in environment like temperature, humidity, like this, and the pig's activity and ethological indicators. In this study, I select the parameters like which section pigs prefer to stay in the pig band. So the So the title is analysis of pig tendencies to stay specific section within the pig band according to environmental parameters and facility features. And the objective is to identify the distribution of environmental parameters across different sections within the experiment pig band. And second thing is to quantify the tendency of pigs to stay in specific sections within the pig band based on the environmental parameters, temperature, relative humidity, and carbon dioxide concentration. So let's move to the materials method. There is a flow chart, like an overview. Firstly, the data collection and data pre-processing and data analysis. So let's go to the details. I conducted the experiment in the Gyeongsang National University experiment pig band. You can see the figure 2. And in this study, the parameters are like this: indoor temperature, IT, indoor relative humidity, IRH, indoor carbon dioxide concentration is ICO2, and has number of pigs in the imaging, in the section, is pig. So I used the sensors, the pig, you can see the figure 3 sensor and RGB 2D camera. So before that, when I want to know which section pigs is staying, so firstly I divide the section in the breeding space. The sections are 12, and the area is almost 1 meter square. And then I assign some facility features like a heat feeder, ventilation fan, and drinker. So you can see the table 1. The section A have the TSW. TSW means 2 side walls, or OSW 1 side walls like this. Then in the imaging, when I check where is the pig. So firstly, it's the low data, the low imaging, and I draw in the pig band using the lacquer spray. Then in the Python code, I draw the line for all images. Good. Okay, go to the result and discussion part. In the objective 1, I want to know the distribution in the pig band, distribution of environmental parameters in the pig band. So this figure 5, we can see the trend in the pig band in the whole section. And in the table 2, there is a correlation coefficients. We all know the relative humidity and temperature have negative correlation. So in this study also, the correlation coefficient is negative, and in the table 3, we can see the IRH, IT, and ICO2, or highest, lowest, and standard deviation. In the temperature case, the highest is 25.1, lowest is 14.3. Is almost optimal condition, but some reference they said the optimal temperature for the growing finishing stage pigs is about 16 to 24 degrees Celsius. But in this study, a little gap, but no, I think it's enough. And then the ICO2, carbon dioxide concentration is in the pig band is almost is the highest average is 1,850, and lowest average is 1,038 ppm. Some reference they said that if carbon dioxide side affect to pigs, like pigs respiratory or disease. It have to be 14,000 ppm like this. At that time, the pigs cannot breathe properly like this. So in this study, the ICO2 is optimal, similar to optimal conditions. And then in the figure 6, this graph shows each section have the average parameter, environmental parameters. So, we can know some difference in each section, and ICO2 also the little gap from each section. So I separate more high than average temperature related humidity ICO2. You can see the table 4. Figure 3, you can see, then understand easily. In the section HIJKL is close to the door. These sections have a more high average, more high relative humidity than other sections, and then the temperature also and ICO2 also. But in case of the ABC, in case of the IT and ICO2 also more high than average value because of you can see this graph. This graph means the head of pigs in each section. So the pigs prefer to stay in section A and B, C. So the environmental parameters show the more high than average parameters. Then go to the table 5. This table shows the correlation of the section heads of pig and environmental parameters. In case of the IRH and ICO2N, the heads, the relation show the nothing, but IT and heads show the negative correlation. So we can know about regarding this. The pigs prefer to stay in cooler space, cooler section in the closed breeding system, breeding space. And finally, the conclusions. In terms of the objective 1, that the difference in environmental parameters across the sections were statistically significant, and then the environmental parameters that most significantly influenced pig's choice prefer to resting section was temperature. You can see the previous slide, the correlation showed the negative, and the pigs were most frequently observed in the sections surrounded by 2 walls. I forgot to mention about this. In the A, C, F, I, most observed the pigs in the section. You can see the A, C, like this, 2 wall. Then after that, the inclusions, in this study, the findings indicate that pigs prefer staying areas with the relatively
lower temperature, cooler space, and surrounded by two walls. Then I think in this study I have some limitation. So in the future studies should investigate not only the air temperature, but also the floor temperature and different flooring materials like soil, plastic, and other things. And then the various growth stages of pig. The optimal temperature regarding the growing stage is very different. For example, the baby piglet, the optimal temperature of piglet is over the 24 degrees Celsius, but the finishing stage optimal temperature is 16 to 24 degrees Celsius, like this. So we have to investigate, study about this, and then therefore it is expected. I expected that this study can serve as a reference for designing pig barns that consider the pig's natural instinct for resting and express sections. Especially, it may guide the design of resting spaces by addressing air temperature, flooring materials, and floor temperature, and other things. I hope that. Thank you very much.
Then, today final closement, I will say that this conference is occurred from 15 years ago. That today is not competition. That only practice, learn. That is, as Pastor please easily asking, easily question. Please try. That is. And after you will have chance in only big conference, then happy, enjoy easily. It's cannot okay. That is, don't understand English, don't understand Japanese, don't understand Korean, Thailand. It's all over okay. That is not anxious. That is that Sato先生どこに行くの？That is, 日本語では全然please ask 日本語とタイランド後で私が説明するんですけど、15年前に初めにこのシンポジウムやる時にはそうでしたけど。このシンポジウムは教書じゃないですよ。ですので練習するとかルーンとか、ですのでいずれ、質問してとかなんとなくできますから、You know now understand my mean? Little? That is Thailand.
ก็มันเป็นงานสัมมนาเนาะสำหรับภาษาไทยคือเด็กๆไทยฟังออกแล้วเนาะก็คืออาจารย์อยากให้มีการดิสคัสโต้ตอบกันแล้วก็คิดว่ามันคือการพยายามที่จะทำกิจกรรมร่วมกันในทางวิชาการเพื่อก้าวไปสู่การเป็นมืออาชีพในอนาคตเพราะฉะนั้นเนี่ยให้กล้าถามเนาะกล้าตอบแล้วก็พยายามที่จะดิสคัสกันทำตัวให้สนุกเนาะเรียนรู้ไปด้วยแล้วก็สนุกไปด้วยสำหรับทุกคนนะคะสำหรับขอให้มันสนุกแล้วก็ตื่นเต้นกับคำถามค่ะขอบคุณค่ะ
사바티카 저기 하여튼 그 너희들도 마찬가지야. 이게 연습이야 연습. 절대로 뭔가 긴장하고 그럴 필요가 전혀 없어. 뭐하러 내가 못하면 못돼서 여기 뭐 상 받으러 온 것도 아니고 그냥 편안하게 그러면서 조금씩 너희들의 실력들이 증가하는 거야. 그래서 지영이 시간 내가 좀 줄여줬지?
Thank you for the teacher advice. And thank you for your presentation. And next, invite to Shi Yong Kang to presentation.
Okay. Hello, everyone. I am Chiang from Smart Space Sensing Laboratory at Gyeongsang University. Today, I will present my research on the stress and soil behavior analysis rotary blades. This presentation is divided into 4 sections: introduction, material methods, result and discussion, and conclusion. The behavior of soil during rotary blade rotation is complex. Understanding this interaction is crucial for assessing blade stress and soil disturbance. In agricultural environments, dynamic loads are not constant, making real-world experience costly and time-consuming. Simulation, however, offer an efficient alternative by reducing time and cost while ensuring safety. The object of the study is to simulate rotary blade and soil interaction to improve the performance and design safety. This study utilized a simulation program capable of performing thermal, fluid, and multi-body dynamics analysis. Key steps include first, inferring material properties such as Poisson ratio and Young's modulus. Second, uploading 3D model of rotary blades and soil. Third, defining boundary conditions like velocity and constraints. Modeling the rotary blade and soil flame, and using particle-based method to simulate soil deformation. Boundary conditions and mesh setting were optimized for accuracy and combination efficiency. The table on this slide shows properties of soil and the properties of alloys used in rotary tools. These values have been used in simulation. The result revealed stress concentration on the rotary blade at specific points like holes and curved sections. The static analysis was performed using the static structure of option in N6, applying a rod to the fixed rotary tool. To model the behavior, a mesh size of 2 mm is specifically required. However, what this mesh size, the simulation failed to learn property to do this excessive number of the nodes. The following image shows the motion of the simulation that was run without reducing the mesh size. The tool ends up bouncing off the soil instead of penetrating it. To address this, simpler methods like water are used in primary analysis. Dynamic simulation shows how stress varies during operation. Both dynamic analysis show that stress constraints on the holes and curved surface of the rotary blade. Future work will focus on optimizing mesh size and reducing stress concentration on rotary blades. Thank you for your time. Bye.
conclusion and I'm currently the purpose of finding on operating mesh size, and so どんなサイズだと思ってますか？具体。
どんなサイズですか？Good. What?
そうね。日本語で。
This mesh is used. .5 millimeter used in mesh size.
Excuse me, please summarize the answer and question.
So, what is the material you used to make the rotary blades?
Yes.
What kind of material?
Oh, sorry, I don't understand. Oh, sorry.
So, what kind of material you use to make the blades? It's a plastic or something else?
This is steel. This rotary blade makes alloy.
It's steel?
Yes.
Okay, thank you.
Thank you for your presentation. Now end session 2 as Chi Yong Kang. While Haram Ji Yeon will be first in session 3. Session 3. The next step will be a lunch break.
Okay, thank you for everyone for joining the presentations on second 1 and 2, right? So right now, so the time for lunch time, and then so we will move for lunch and the 7th floor. Yeah, so and we have time for lunch around 1 hour, and then we will back again in this room. Yeah, okay, see you. Thank you.
จากเมล็ดข้าวเล็กๆที่หว่านลงบนผืนนาความอุดมสมบูรณ์แห่งดินและน้ำบ่มเพาะให้ข้าวเมล็ดนั้นเติบโตงอกงามเต็มท้องทุ่งพร้อมจะแปลเปลี่ยนให้เป็นจากเมล็ดข้าวเล็กๆที่หว่านลงบนผืนนาความอุดมสมบูรณ์แห่งดินและน้ำบ่มเพาะให้ข้าวเมล็ดนั้นเติบโตงอกงามเต็มท้องทุ่งพร้อมจะแปลเปลี่ยนให้เป็นอาหารแก่คนทั้งโลกเช่นเดียวกับวิชาการเกษตรที่เริ่มอย่างรากลงผืนเป็นดินไทยอย่างจริงจังเมื่อกว่า80ปีก่อนเวลาที่ผ่านเกิดการสั่งสมแสวงหาและพัฒนาความรู้ให้เจริญงอกงามเพียบพร้อมด้วยวิชาการเพื่อนำไปสู่การพัฒนาประเทศอย่างยั่งยืนด้วยคณะวิชาที่หลากหลายและหลักสูตรที่มีคุณภาพจำนวนมากซึ่งครอบคลุมศาสตร์ทุกแขนงทั้งในระดับประกาศนียบัตรระดับปริญญาตรีและระดับบัณฑิตศึกษานี่คือมหาวิทยาลัยเกษตรศาสตร์มหาวิทยาลัยแห่งการเรียนรู้วิจัยและสร้างนวัตกรรมระดับโลกเพื่อการพัฒนาอย่างยั่งยืนบนพื้นฐานของศาสตร์แห่งแผ่นดินตลอดเวลากว่า8ทศวรรษมหาวิทยาลัยเกษตรศาสตร์คือผู้นำด้านการศึกษาวิจัยและนวัตกรรมให้บริการวิชาการแก่สังคมทั้งในสาขาเกษตรและสาขาต่างๆที่มีความจำเป็นต่อการพัฒนาประเทศเป็นมหาวิทยาลัยในกำกับของรัฐที่ขยายโอกาสทางการศึกษาเพื่อรองรับการเติบโตในทุกภูมิภาคของประเทศโดยให้สอดคล้องกับวิถีชีวิตของชุมชนในท้องถิ่นมหาวิทยาลัยเกษตรศาสตร์บางเขนจุดเริ่มต้นของมหาวิทยาลัยเกษตรศาสตร์ศูนย์กลางการเรียนหลากหลายสาขาวิชาที่สนับสนุนการพัฒนาประเทศในทุกๆด้านเติบโตพร้อมๆกับการพัฒนาหลักสูตรเพื่อรับใช้สังคมแห่งความก้าวหน้าทางเศรษฐกิจและเทคโนโลยีพื้นที่กว้างใหญ่ในเขตอำเภอกำแพงแสนจังหวัดนครปฐมได้ถูกพัฒนาขึ้นเป็นมหาวิทยาลัยเกษตรศาสตร์วิทยาเขตกำแพงแสนเพื่อเพิ่มการผลิตบัณฑิตในสาขาวิชาเกษตรและสาขาที่สนับสนุนการเกษตรให้ได้ทั้งปริมาณและคุณภาพทางวิชาการมหาวิทยาลัยเกษตรศาสตร์วิทยาเขตเฉลิมพระเกียรติจังหวัดสกลนครคือการขยายโอกาสทางการศึกษาสู่ภูมิภาคตะวันออกเฉียงเหนือเพื่อผลิตบุคลากรสนับสนุนการพัฒนาและช่วยเหลือเกษตรกรในท้องถิ่นตามโครงการพระราชดำริต่างๆ การ การขยายตัวของเขตเศรษฐกิจชายฝั่งภาคตะวันออกเป็นที่มาของการจัดตั้งมหาวิทยาลัยเกษตรศาสตร์วิทยาเขตศรีราชาเพื่อสร้างบุคลากรและเสริมสร้างความมั่นคงทางวิชาการที่สอดคล้องกับการเติบโตทางเศรษฐกิจมหาวิทยาลัยเกษตรศาสตร์เปิดกว้างในการนำเทคโนโลยีที่ทันสมัยมาใช้ในการเรียนการสอนโดยให้ผู้เรียนเป็นศูนย์กลางแห่งการเรียนรู้ด้วยการถ่ายทอดศาสตร์ความรู้อย่างครบวงจรมุ่งเน้นการพัฒนาสู่ความเป็นมหาวิทยาลัยวิจัยด้วยการส่งเสริมและสนับสนุนการศึกษาวิจัยอย่างหลากหลายสาขาวิชาโดยเฉพาะด้านที่มีส่วนในการสร้างความกินดีอยู่ดีให้กับคนในประเทศด้านการแพทย์ด้านเวชศาสตร์การเกษตรและด้านสิ่งแวดล้อมซึ่งตั้งเป้าสู่ความเป็นกลางทางคาร์บอนอย่างเป็นรูปธรรมภายในปีค.ศ. 2035มหาวิทยาลัยเกษตรศาสตร์ไม่เพียงให้ความสำคัญกับวิชาการเท่านั้นแต่ยังเสริมสร้างความรู้คู่คุณธรรมด้วยการสนับสนุนและอนุรักษ์ศิลปะวัฒนธรรมศาสนาประเพณีต่างๆเพื่อให้นิสิตเกษตรศาสตร์ทุกคนเป็นผู้มีความรู้ความสามารถและมีจริยธรรมสามารถออกไปรับใช้สังคมได้อย่างมีคุณภาพมหาวิทยาลัยเกษตรศาสตร์ภาคภูมิใจที่ได้เป็นส่วนหนึ่งของสังคมไทยด้วยการผลิตบุคลากรหลากหลายสาขาอาชีพเพื่อเป็นฟันเฟืองสำหรับขับเคลื่อนและพัฒนาประเทศเป็นศาสตร์แห่งแผ่นดินโดยแท้จริงดั่งเมล็ดข้าวที่ถูกหว่านลงบนผืนแผ่นดินในวันก่อนเติบโตผลิดอกออกรวงกลายเป็นแหล่งอาหารที่สำคัญของคนทั้งโลก
Let me start the afternoon, the seminar. That is, please keep the chair. Is it possible early finish that after dinner party for drink, right? Sorry, I intercept the chair. So afternoon sex first time is 7 president. That is 6. Also remained the before noon the president the Haramjan is firstly start from Haramjan. Is please prepare the Haramjan. Yeah, sorry, that is remained one people. Also one thing is as possible, please prepare the question. The other country, right? Is all over okay. Is cannot understand any research area. That is common asking is okay. There is, for example, want to asking the name and any age is all over okay. That quickly keep the one question. Other country. Right? Understand the who is this? Uchida, where is the Japanese student? Please call. Then please keep the chair. Okay, Haram, please prepare your presentation. Also, one people is 12 minutes. That is, please finish the 10 minutes. As possible, 2 minutes. We'll use the Q&A. Then. Haram, is okay?
네.
So,
네.
Please, let's start. You know what?
일부러. Okay. I will start presentation. Good evening, everyone. Thank you for joining today. My name is Haramjan, and I am pleased to present our study title, comparative study on growth rate of strawberry cultivates in different cross states in controlled environment agriculture. This research conducted under the guidance of Professor Hyun-taek Kim and in collaboration with my team at Gyeongsang National University in South Korea. This picture in my plant factory pictures. This plant is 금실, okay? Controlled the environment agriculture, or CA is a cutting edge approach that enables precise control of environment factors like temperature and humidity and lighting, optimus agriculture production. Strawberry is a high demand fruit grown globally. Your ideal candidates for studying these techniques. The objective of our study are threefold. One, to compare the growth rates of three strawberry cultivars, 서량, 금실, and 홍이, across different growth stages. Two, to optimize growth rates for maximizing growth efficiency and fruit products in controlled environment. Three, to contribute to breeding programs by identity optimal growth traits and enhancing yield prediction through improved predictive models. Our experiment was conducted in a container farm at the Smart Spacing Laboratory in Gyeongsang University. The container farm provides a control environment with regulated temperature and humidity and lighting. We worked with three strawberry cultivars. 서량, 3 red 150 plants, popular cultivars in South Korea, known for its balanced growth. 금실 is 400 plants, valued for its high-quality fruit. 홍이 is 30 plants, a newer variety with unique growth characteristics. The controlled environment, the character environment allowed us to isolate the effect of the microclimate on the cultivate and productive. We collected data bi-weekly, focusing on different growth phases. 1. Vegetable growth. 2. Flowering. 3. Fruit development. 4. Fruit ripening. For each phase, we recorded growth data, plant height, leaf length and width, number of leaves, flowers, and fruits. Fruit data, weight, size, and quality measured in terms of sugar content. Microclimate data, parameters like temperature and humidity, CO2 concentration, and nutrition levels. The container farm microclimate environment was precisely managed. Key parameters included temperature 30%, 5 temperature 30.5 to 22 degrees C. Humidity 70 to 19%. Photo period 10 hours of light and 12 hours at 40 hours of darkness daily. CO2 concentration 400 to 450 ppm. Irrigation and nutriment provided based on recommended agricultural standards. All controls were monitored and managed through an Android app called PalmLink, which provided real-time data and ensured consistent environment conditions. In terms of yield and quality, Seoryang excelled in total fraud weight and number, making it suitable for mass production. Kumsil produced fruits with the high sugar content and rice size. Hongi showed potential as a niche variety with consistent quality in later growth stage. Data not only highlights the importance of cultivate collection, but also demonstrates how controlled environments can optimize different strategies. To conclude, controlled environments enable precise management of growth conditions, allowing us to maximize both productive and quality. Culture-based collection is key. Seoryang for high yield, Kumsil for quality, premium quality, and Hongi for potential niche market. Moving forward, we plan to expand this study to include more cultivate and connect long-term evaluation to assess economic feasibility. Initially, we aim to refine predictive models for yield forecasting, average the data collected in this study. Thank you for listening.
Can I see slide number 2?
Number 2.
Next one, and next one. Thank
one?
you. I want to ask about what's the difference of 3 cultivators, Hongi and Gums.
금실 and Seoryang. Yes.
One more time, please. One more time, please. What's the difference of 3 cultivars? The 3 places, right?
Yes, three plants. Different 품종?
It's a kind of
Cultivate.
place.
Yes. 다른. Name is Seoryang, 금실, 홍이.
The place of
Yes.
name of place.
Different strawberry.
Different strawberry.
Yes.
I see. Thank you.
Okay.
Why you use these 3 differences, but why you use these 3? Difference of the type of seeds. Why you use only 3 but
yes.
have a lot of seeds of strawberry?
First, Seoryang is many Seoryang is Korean people very like strawberry. So first reason is contact Seoryang, and 금실 is Korean 품종? 품종은 뭐라지? 코리안 품종. 교수님 혹시 품종을 뭐라 하죠?
Thank you for your presentation. ย้อน Next, I would like to invite Sang Hyon Shin to deliver their presentation.
Hi everyone, long time no see. First of all, I'm Sang Hyun Shin, Department of Smart Farm at Gyeongsang National University. Today my presentation title is Prediction of Carbon Dioxide Concentration in Strawberry Greenhouse by using time series models. Today's content is following this page. First of all, go to the introduction. Recently, the agriculture workers are gradually declining due to the aging and lower interest rate of young generation. Here in Korea, farmers are using big data that are collected from various farms for the development of agriculture automation systems, which expected to lead the future of agriculture. In this study, I used the CO2 concentration data because it is essential to monitor and management CO2 concentration in greenhouse environments to optimize the growth and productivity of strawberries. That's why I used this data. In this study, three kinds of objectives. First, building time series models for hourly CO2 predictions. Optimal high parameters are selected to accommodate various collection intervals. Second thing is comparing the accuracy of our model using 5 different data sets. And last objective is comparing the performance of 2 time series forecasting model for prediction CO2 concentration. Okay, let's go to the material method part. This figure, you can see the experimental greenhouse and strawberry. In this study, cultivated crops is strawberry and cultivar is sarhang strawberry. Greenhouse size, you can see in this page. This figure 2 can show the air heating fan and CO2 sensor. First of all, I used the sensor. Honestly, it can collect temperature and humidity and CO2 concentration, but in this study, I used only CO2 concentration data. Instrument is used to maintain temperature levels of the greenhouse. Also, this air heating fan is installed on the top of the greenhouse and 24-hour variable temperature. The data was collected from January 1 to April 20, 2022-24. Also, data collection cycle is 1 minute interval. Finally, using the average of 15 data. This figure can show the flow chart of the study. Sensors are installed to measure and record CO2 concentration, and the collected data undergo pre-processing to ensure suitability for analysis. Time series models are applied based on historical data to forecasting future CO2 concentration, involving steps like feature selection and model training. Finally, the prediction data are analyzed to identify trends, and environmental management strategies are formulated based on this insight. After data collected, I conducted data preprocessing. First of all, missing data were addressed through linear interpolation. You can see the figure 4, and our linear were identified and removed using IF algorithm. You can see the figure 5. After data preprocessing, I conducted time series analysis. First of all, it is important thing is understanding the phenomenon and predicting the future. You can see the flow chart in this figure 6 regarding time series analysis. Can simple from the past to present to predict the future by understanding the change in phenomenon. My first time series analysis model is ARIMA model. This model is consisted to AR and MA and stationary, 3 kinds of things. The data must be stationary. You can see this figure regarding stationary condition, and the model must transform the data to normal through differencing. This model is in which difference is performed d times on the ARIMA models. Second time series model is Profem models. This model is the composable time series forecasting model developed by Facebook. This model is powerful yet user-friendly, providing fast and accuracy forecasting for data that change over time. In this study, the default setting of the model were employed. This figure 8, you can show the flow chart of the Profem model. After modeling, I used the model performance, these 3 kinds of things. You can see regarding equations, RMSE and R square and MAE. Okay, let's go to the result and discussion part. In this study, the autocorrelation structure of 5 datasets with varying collection intervals was analyzed using ACF and PACF diagram. You can see in this figure 9, as a result, an ARIMA 201 model was selecting for the CO21 dataset. Also, regarding CO260 dataset, I used the selecting PDQ value for the ARIMA model by using ACF and PACF diagram. Based on the common patterns observed in the ACF and PACF on ARIMA 202, models was chosen for the dataset with remained for dataset. In this figure, you can see the evaluation matrix result of ARIMA model for CO2 concentration prediction. On the left side of the picture, graph A means training result, training model performance result, and on the right side of the picture, figure B means the testing model performance result. Overall prediction result of both training time and testing time are satisfied in the ARIMA model. And next thing regarding Profem model, the evaluation matrix result of Profem models. Similarly, previous page on the left side of the picture means the testing result model performance, and on the right side of the picture, graph B means Profem model testing performance result. Similarly, previous page result, the ARIMA model outperformed the Profem model in predicting CO2 concentration occurs in interval dataset. Okay, on the left side of the picture, figure 13, you can see the comparison of observed and predicted values using ARIMA for CO2 concentration prediction. In orange color lines means prediction data, and blue color lines means actual data. And table 1's mean is model performance under CO2 data. You can check the result, detailed result using this table 1. Shortly, I can tell the training data and testing prediction performance demonstrated that CO2 dataset achieved the best performance in prediction CO2 concentration compared to other datasets. This figure, you can see the comparison of observed and predicted value using Profem model for CO2 concentration prediction. Line color is same previous page. Also, table 2 means regarding Profem model CO2 dataset. It also simply, I can say, the training and testing prediction performance demonstrated that CO2 dataset achieved the best performance in this dataset. Okay, let's go to the last conclusion part. Shortly, I can say the ARIMA model outperforms the Profem model in predicting CO2 concentration across all interval datasets. Determining the optimal collection interval is crucial as the frequency of data collection directly influences the accuracy of model prediction. Selecting appropriate data points and variables in both models can enhance prediction accuracy and maximize model performance. However, too much input variable can increase the complexity of the model and extend computation time. It is important to focus on developing prediction models that consider seasonal change and a newer variable through long-time data collection and analysis. Thank you for listening, and if you have any questions, please feel free to ask me. Thank you so much.
Thank you, Mr. Sang Hyun Shin. Please invite the question.
How does carbon dioxide concentration affect strawberry?
Can you tell me page number?
I didn't know which page, but I just want to know how carbon dioxide concentration affect the strawberry.
Okay. Okay, simply I can give you the answer. First of all, thank you so much your question. Regarding your question, I can say the CO2 is important to monitoring and management CO2 concentration in greenhouse environment. So many papers can show the enhance the yield and size of the fruit and result in higher contents of activity, like vitamin C and something like good contents. So I think for me, that's all. Thank you.
It's so carbon dioxide impact in the positive way, right?
Yes, regarding your question, you can see on the right side of the essay.
Okay, I see.
Okay, thank you so much.
Thank you for your presentation. Next, I would like to invite Supansa Chaipong to deliver their presentation.
Okay. Good afternoon, everyone. My name is Supansa Cheyapong. Today, I am pleased to present our research titled Soil Carbon Dioxide Emission and Carbon Dioxide Absorption under different tree species of dipterocarp forest and evergreen forest at Scalar Environmental Research Station. Our research focused on two forest types, dipterocarp forest and evergreen forest, located at Scalar Environmental Research Station. This forest represent key ecosystem in Thailand with significant role in carbon storage and emission. Our main objective are to evaluate the biomass and carbon dioxide circulation in the soil with different tree species in dipterocarp and evergreen forest. 2. Evaluate the carbon dioxide released from soil with different tree species in dipterocarp and tropical rainforest. And 3. To compare the carbon dioxide released from soil and carbon dioxide uptake with different tree species in dipterocarp and evergreen forest. Okay, study area. The study area is the Scalar Environmental Research Station located in Wang Nam Khiao, district in northern Thailand. This station functions as a vital research center for plant species in the region forest. Okay, equipment. This image shows the equipment used to collect species data to study soil carbon dioxide emission and carbon dioxide absorption. The main equipment used is diameter tape, which is used to measure the circumference of tree. Tape, which is used to lay out plot for data collection. GPS, which is used to identify the coordinate of data collection point. Method of data collection. Through charity, we can restore damaged forest, reduce pollution, and even create jobs in environmentally friendly sectors. This not only benefit nature but also local community and future generation. One press a 10 meter pot. The S coordinate of the 10x10 meters sample pot were collected at every corner of the pot and the slope value we collected at the center of the sample pot. 2. Measure the diameter tape at the blade. Data on the on diameter tape at rate high dBH greater than or to 4.5 cm and high greater than 1.30 meter were collected for all rate T in the pot. And to measure the height of all rate T. This is the formula for calculating the biomass of both forest type named diphthalocarbon and evergreen forest to see the carbon dioxide emission value and the formula for calculating the carbon dioxide absorption value. Okay, now let's look at the result of carbon dioxide emission in the diphthalocarbon forest. The result of the study found that the carbon dioxide emission in the diphthalocarbon forest, the species with the high carbon dioxide emission value was Lotmania viti, which has a value of 0.61, which was higher than other species studied. Characteristic of other species in diphthalocarbon forest.อันนี้จะเป็น research result carbon dioxide absorption diphthalocarbon forest. The result of the study found that the carbon dioxide absorption in the diphthalocarbon forest species with the high carbon dioxide absorption value was petrocarbon, macrocarbon with a value of 8.28, which was higher than the other species studied. Characteristic of other species in the diphthalocarbon forest. Research result evergreen forest soil carbon dioxide emission. The result of the study found that the carbon dioxide emission in the evergreen forest, the species with the high carbon dioxide emission value was Hydrocarbus elephant foliaking, which has a value of 0.74, which was higher than other species studied. Characteristics of other species in the evergreen forest. Research result evergreen forest carbon dioxide absorption. The result of the study found that the carbon dioxide absorption in the evergreen forest species with the high carbon dioxide absorption value was gallium cochinate pairing with a value of 5595.94, which was higher than the other species studied. Characteristics of other species in the diphthalocarbon forest. Consumption. The study of the emission, intimation, and compression of carbon dioxide emission from soil and carbon dioxide uptake under different species in diphthalocarbon forest and evergreen forest as Scala Environmental Research Station should have additional study sure at factor affecting carbon dioxide emission for soil and carbon dioxide absorption. Thank you very much.
Thank you, Mr. Supansa. If you have a question for her.
Thank you, Supansa, for your good presentation. I have a question, actually. How did the three species you considered in the picker-up forest and dry evergreen forest, you said you measured 10 by 10, the study area. So how did you select the areas to measure in those two forests? And because if you don't accurately select those areas, how can you conclude that this particular tree species has the CO2 emission? So that is my question. Thank you. How did you select the area to measure the CO2 emission in the dicapero forest and the dry evergreen forest?
Okay. I think biodiversity and different environmental scala in environmental research station is an important research center as per the study of the diversity of plant and animal in the high tropical dipterocarp forest and evergreen forest.
Thank you.
Did you understand?
Thank you very much.
Thank you for your good presentation. I ever went to the research center, Sakarat, so I love the environment of there. But I would like to know that why the green evergreen forest more carbon dioxide there. In your research, it shows that dry evergreen forest has more carbon dioxide, but why, in your opinion?
Okay. I think from study at Scala also help to conserve forest and biodiversity in the area by monitoring forest condition and studying long-term Change in the ecosystem which is important information for forest conservation in the western part. Yeah.
Thank you.
Thank you for your presentation. Next, I would like to invite Yun Ik Chuang to present.
Okay. Hello everyone. I'm Yunik Zhang, an undergraduate student of Smart Space Sensing Laboratory. Today, I present my research of analyzing carbon dioxide consumption based on K-lift area. First, let me explain the research background. Recently, smart farm and indoor cultivation system have gained significant attention worldwide. Smart farming is an efficient cultivation method that enhances crop productivity and adapt to environmental changes, and its application is rapidly expanding globally. And in South Korea, where seasonal weather changes and climatic variability are prominent, the need for the smart farm has become increasingly critical. For instance, in 2022, the land area for controlled horticulture in South Korea increased by almost 60% compared to 2018. This rapid adoption highlights the growing importance of smart farm technologies and cultivation methods in adapting to environmental challenges. And one of the key aspects of smart farming is optimizing environmental variable. Among these variables, CO2 plays a vital role in plant growth and photosynthesis, directly impacting crop productivity. Thus, understanding the relation between CO2 concentration and plant response is crucial for enhancing the efficiency of indoor cultivation system. So, and I choose the kale as the subject of my research because kale is a nutrient-rich vegetable that contains essential vitamins, minerals, and other nutrients, making it highly demanded in recent years. According to the USDA, the global supply of kale has been steadily increasing, indicating its growing popularity and demand. Its unique characteristic, including the clear relationship between leaf area and CO2 solution, make it an ideal subject for this study. So this research aims to understand photosynthetic mechanism in plant and provide supplementary data to existing study. Now I'm telling my research progress. The experiment was conducted in the plant factory at our smart space sensing laboratory. The environmental conditions were set as follows. The temperature was maintained 32 degrees. The light intensity was set to 7,000 lux, and the humidity was controlled at approximately 50%. So to measuring data in shared environment, I made a 20 centimeters acrylic box by using a laser cut, 20 centimeter laser cut panel. Each box was equipped with a CO2 sensor installed inside, and all gaps were sealed with glue to ensure complete air tightness. This careful design was essential for measuring accurate change in CO2 level without interference from external air. For this experiment, the sensor displayed here was used to measure changes in carbon dioxide concentration. This sensor can collect data every second, enabling precise analysis of CO2 variation over time. And the kale used in this experiment was cultivated in soil mixed with cocopeat, peat moss, vermiculite, and perlite. Capsule fertilizers containing nitrogen, phosphorus, potassium, and calcium were applied. After 6 weeks of growth under identical conditions, three kale samples with different leaf area were selected for the experiment. The experimental process was as follows. Kale sample A, B, and C were placed in sealed acrylic boxes, and their carbon dioxide absolution level were monitored for 5 hours. After each session, the leaf area of each kale sample was measured using a 3D scanner. This process was repeated over 3 days to collect reliable data. As a control, the ambient CO2 concentration in the plant factory was also monitored. A 3D scanner was used to measure the entire surface of area, include the curvature of the leaves. The scanning was conducted from a distance of approximately 40 centimeters to ensure accurate result. The scanner data was processed using Flex 3D software to calculate the surface area. This allowed to obtain precise measurement, not limited to flat projection of the leaves. Now, let me share the result of the experiment. The data show that larger leaf area corresponded to increased carbon dioxide consumption. However, there were limitations, such as inability to standardize the initial carbon dioxide consumption and measurement error in leaf area data. So thus, further experiments are needed to achieve a more accurate analysis. So additionally, I wanted to know whether the thickness of kale leaves also affecting carbon dioxide consumption while I'm performing my experiment. So I plan to include kale sample with varying leaf thicknesses in future experiments to analyze the relationship between thickness and carbon dioxide consumption. So the title of my next experience will be like analysis of effect of kale leaf area and thickness on carbon dioxide consumption. I aim to collect a larger volume of data to identify patterns related to both leaf area and thickness. Through this, I hope to provide a more comprehensive understanding of carbon dioxide consumption in plant. In future experiment, I will address the limitation of this study to obtain more reliable data. Thank you for listening.
Thank you, Mr. Yun Ik Swang.
Okay, thank you presentation. Why did you choose scale as your research subject?
Okay, thank you for your question.
Okay, thank you.
Because kale has many nutrients and additional nutrients and vitamins, and in global market, kale market is have many supply, so I choose the kale. That is religion.
Okay, thank you.
Thank you.
First, thank you for the presentation. My name is Pansip.
Yes.
Can you tell what you will do in the future?
I do future.
Okay.
Future plan.
The future plan that you say that you will do. Yeah. Can you say it again?
Thank you for the question. I do measuring about kale leaf and thickness. Leaf also has a small thickness. It's very small, but it has. So I think maybe leaf thickness is affect to carbon dioxide consumption. So I wanted to know its effect or not.
Now you just only focus on the size, right? For the area on the leaf.
Yeah, leaf side area.
Next week, okay.
Yeah. Thank you.
Thank you.
Thank you for your presentation, Mr. Yong In Zhuang. Next, I would like to invite Jong In Choi to presentation.
Hello, good afternoon. I will present my research on lettuce grow under pressure change. The presentation will proceed in the following order: introduction and material and method, research and discussion, and conclusion. First, introduction. Currently, space mission depend on the delivery of food and resource from us. However, transporting these supplies costly and the risk and restrictions increasing significantly with greater distance. To solve this problem, it is essential to develop a self-sustaining system for food dispensation. This involves cultivating plants capable of stable growth in extreme environments such as low pressure and low gravity. To achieve this goal, it is crucial to establish a system that can precisely regulate environment factors, including temperature, humidity, pressure, light, and CO2 concentration. Simultaneously, it is important to research plants that can thrive in a space environment. Developing this technology will enhance the autonomy of space exploration and potential land to innovative agriculture systems. This advancement could help address global food shortages caused by climate change. Lettuce was selected as a experimental crop, and 3 different pressure levels were set for the study: atmospheric pressure, intermediate pressure, and low pressure. Each group included 3 samples, and 2 sets were formatted for each group for dependence experiment under the same conditions. The experiment was conducted for a total for 19 days, and data were collected on day 1, 9, and 19. The collected data analyzes the growth status by measuring the leaf length and width of the lettuce and the chlorophyll content at each time point. The experiment was conducted in a chamber made of alex, where LED lights were used to support photosynthesis in plants, and photographs were taken using an RGB 2D camera. Furthermore, changes in environment factors were magnetic in real time through temperature and humidity sensors, and pressure conditions for each group were controlled using pressure gauges. Experimental research showed that atmospheric pressure left lengths increasing significantly over time, with significantly growth observed, particularly on the 19th day. In contrast, under low pressure conditions, there was little or no change in leaf length and especially under 33 kilopascal conditions, leaf length remained almost constant from day 1 to day 19, showing that leaf growth restriction in the low pressure environment was predominant. For leaf waters at 101 kilopascal, it showed a pattern of steadily increasing from day 1 to day 9 and then decreasing on the 19th. And at 67 kilopascal, it initially increased but then decreased and returns to a level similar to day 1. At 33 kilopascal, there was a initially small increase followed by a tendency to remain stable without significant change until the 19th day. Chlorophyll concentrationally decreased continuously over time under atmospheric pressure condition, but under 67 kilopascal conditions, there was an inter-decrease followed by a small increase, but overall it remained at a low level and recording a value lower than atmospheric pressure. In contents in low pressure environment, there was a clean tendency for plant growth to be restricted, and in particular under 33 kilopascal conditions, there was less change in leaf length and a unique pattern of increase in chlorophyll concentration was confirmed. This could be interpreted as a response by plant absorb more nutrient to survive in extreme environment. This research suggests that low pressure environment have a negative effect on plant growth, with low pressure showing down growth. This experiment confirmed the effect of low pressure environment on plant growth, and in particular it was observed that as the pressure decreased, the growth rate of plant showed down the chlorophyll concentration increase. Thank you for listening.
Thank you for your presentation. If anyone has a question, you may ask the presenter.
Thank you for presentation. Slide 7.
7?
Yeah. What is purple in the figure 3? What is purple? Picture? Yeah. Why is color purple?
거품이요? 동그라미 흰색? sorry. 뭐 어떤 색깔이요? LED 컬러.
일단 thank you.
Hello, I'm Muk. I have a question. Why does the length increase significant under atmosphere pressure? 101.3, but show less thickened growth at lower pressure or 33 kilopascal. Leaf length.
Sorry. I'm sorry that I'm not good at English. Okay.
Thank you. Thank you for your presentation. Next, I would like to invite Piyatida Kongtip to present.
Good afternoon, everyone. I'm Piyatida Kongtip. I'm a four-year BS student. Today, I will be presenting my research on the topic of soil carbon stock under different species of dipterocarp forest and evergreen forest at Sakarat Environmental Research Station. Introduction. The world is currently facing crisis of air pollution and global warming with the increasing level of carbon dioxide significantly impacting the environment. Impact includes heat retention in the atmosphere, rises temperature, polar ice melting, ocean acidification, and air pollution that affect the health of human and animal. Reduction carbon dioxide emission in therefore crucial. Soil is a major carbon reservoir. There is growing interest in study soil carbon stock. Study area. The Sakarat Environmental Research Station or Scarrat Biosphere Reserve covers an area of approximately 28 square kilometer. It serves as a research center for plant species in the forests of northeastern Thailand. The area consists of natural forests, including two forest types, dry-evergreen forest and dipterocarp forest. It is significant for environmental and tropical forest ecology. Research due to its rich biodiversity encompassing various wildlife species and wide variety of plant species. Objective to assess and compare soil carbon stock in dry dipterocarp and dry evergreen forest with different tree species as the Scarrat development research. Method 1. 1. Collect select data from annual soil carbon stock for the year 2022 to conduct field data collection. Establish 10 multiplied by 10 meter survey plots in both dry dipterocarp and dry evergreen forest with 3 plots per forest type. Measure tree average height 1.3 meter with a GBH more than 4.5 cm. Survey and identify tree species within the plot. Perform ecological data analysis. Analyze species composition and calculate tree value. Analyze species dominance. Analyze species density. Analyze species diversity. Analyze biomass. Conclusion. Figure 1. Bar chart showing compare of biomass and soil carbon stock with tree species in dry dipterocarp forest. The tree species with the highest bio in Pterocarpus macrocarpus, while the species with the lowest biomass is Delvergia. The soil carbon stock level of the three tree species are relatively similar, which Rosmania vitti having slightly higher value than Delvergia and Pterocarpus. Pterocarpus has the higher biology. Its soil carbon stock is not correspondingly high. This suggests that the biomass of tree and soil carbon stock may differ on various factors such as soil type, root structure, or difference in the process of organic matter accumulation in the soil. Figure 2 bar chart showing comparison of biomass and soil carbon stock with tree species in dry evergreen forest. The tree species with the highest biomass is Dalium Cochinchinesis. Why the species with the lowest biomass in Hynocarpus is Phylia. The soil carbon stock level of the three species differ with Dilium Cochinchinesis having the highest soil carbon stock and Hynocarpus having the lower. Figure 3 bar chart showing compression of carbon content and soil carbon stock with 3 species in dry lithocarp forest. The 3 species with the highest carbon content is Pithelocarpus, while the species with the lower carbon content is Dabergia. The soil carbon stock level of the 3 species with Tromania having the highest soil carbon stock, while Dabergia and Pithelocarpus have values that are close to Earth's other. Figure 4 bar chart showing compare of carbon content and soil carbon stock with 3 species in dry evergreen forest. Dilium has the highest carbon content, while Hynocarpus illifolia king has the lowest. Dilium has the highest carbon content in the tree, but its soil carbon stock is not the highest when compared to Hynocarpus illifolia king. This chart shows that soil carbon stock does not direction correlate with the carbon content is the tree, influenced by factors such as root characteristic, organic matter, accumulation in the soil, or the decomposition process in the area. Figure 5 bar chart showing compression of carbon stock and soil carbon stock with 3 species is Lithocarp forest. Dabergia has the highest carbon stock value, while Pithelocarp has the lowest. 2 soil carbon stock value of all 3 pods are similar and do not directly correlate with the carbon stock value. Figure 6 bar chart showing compression of carbon stock and soil carbon stock with 3 species in dry evergreen forest. Hopia odorata has the highest carbon stock, while the 2 pods of Egingia have carbon stock value but are significantly lower. The soil carbon stock in each area is relatively low, with the Hopia odorata pod having the highest value and the second Egingia Mariana pod have the lower. Thank you.
Thank you for your presentation. If anyone has a question, you can ask her.
Okay, thanks for your presentation. I want to know why are you compare uh, Diterocap and evergreen port.
because two type forest have different soil type, root structure, or different in the process of organic matter.
Okay, thank you. Thank you.
Its time is up. If you have any question, you can ask her later.
So thank you for presentation. Question: what additional research do you think are needed in the future?
Ask again, please.
What additional research do you think are needed in the future?
Sorry, I don't know.
Sorry. Sorry. Thank you.
Thank you for your presentation. Next, I invite Eun Wan Saw to presentation.
Sorry, I don't prepare. Hello everyone, my name is Nansa. I master student and my supervisor is Professor Hyuntae Kim, and I belong to Smart Space Sensing Laboratory in Gyeongsang National University. My research title is a predict of feed intake during growing finish stage of figure using machine learning model. My presentation consists introduction, material method, research and discussion, and conclusion. Introduction part. According to Statistics Korea, meat consumption has been increased by average of 4.2% years from 1980 to 2018. Among these, pork has accounted for a large proportion of meat consumption in Korea. According to Statistics Korea, the total livestock income increased by average of 2.2% from 1981 to 2019. But pig barn income decreased by average of 1.8% years from 1981 to 2019. So the largest portion of management cost is
feed cost account for more than 5% of management cost. Pig feed prices are rising every year, causing economic difficulties for pig farm. My objective, this is a parliament aim to analyze the average feed intake of pig at different growth stages and to develop a prediction model for pig feed intake. Material method part. This figure is experiment figure barn setup. Feeder, drinker, indoor pig barn, and ramp sensor, load cell, pig controller. This figure is feed ingredient. During the experiment, feed was providing twice a day at 9 a.m. to 5 p.m. So the amount of feed provided per day was 5% of the average body weight of the pig. This is experiment design. I use a 6 parameter, and later I use a Pearson correlation. And later divide the independent variable and the dependent variable. And I use a full machine learning model. And I will evaluation model. So I use 3 performance method. This is I use regression analysis, multiple linear regression, ElastiNet, support vector regression, and random forest regression. And this is a performance evaluation method. I use MAPE, RMSE, RSQL, and decided to use 80 and 20 data split with 80% as training data and 20% as testing data to achieve the highest accuracy. Research and discussion part. Correlation material analysis research. The analysis research showed a strong positive linear relationship between the feed intake variable and the pig weight variable. And a strong positive linear relationship was observed between pig body weight and ammonia variable. My experiment, the ammonia variable was excluded. The analysis of variance research. The analysis of variance confirmed that there was a significant difference in the pig intake of at each growth stage. Indicating that pig consume a constant amount of feed as they grow. Performance evaluation research. As research of the performance evaluation of each model, the RFR model showed the best accuracy and the SVR model showed the lowest accuracy. This is the testing period, actual, and predict data of feed intake are presented using a full machine learning model. Moreover, the research visualized through scatter plot with one to one line graph. Conclusion part. The feed intake of feed across different growth stage was found to be statistically significant with a consistent amount of feed intake observed and the figure growth. The correlation analysis between variables show a strong linear relationship between the dependent and the independent variable. Strong positive linear relationship was observed between the feed intake variable and the figure weight variable. A strong positive linear relationship was found between the figure weight variable and the ammonia variable in the fig band, leading to the exclusion of the ammonia variable. Last, the performance evaluation of each model showed the random forest regression model has the highest accuracy, where the support vector regression model has the lowest accuracy. This is a reference. Thank you for your attention.
Thank you for your presentation. If anyone has a question, you can ask him.
Thank you for your presentation. I understand from your presentation that feed affects the income of the pig farmer, but what kind of food do pig farmers give to the pig? What kind of food?
What kinds of feed?
Yeah.
So Korean case, Korean company is 농협. 농협 is make feed, pig feed, and other animal also make. So my experiment, my experiment case, I use 농협 company feed.
Okay, I see. Thank you.
Thank you for your presentation. Okay. Why you should support vector and random forest? Because there are so many machine learning options.
The machine learning model is many have a model, but so example, random forest regression is a very powerful machine learning model because this explain very what I call very simple, but I think random forest regression is a very good analysis. So I use this model.
Okay, thank you.
Thank you.
Thank you for your presentation.
감사합니다.
Next, I would like to invite Sang Min Kim to present.
Hello, my name is Sang-min Kim, the presenter of this time. My topic is analysis of plant growth and chlorophyll due to stress based on distance from the rotation axis using a 2D clinostate. In this presentation, I will cover the following these contents. Introduction. A scientific interesting is shifting from the study of the Earth's interior to the study of outer space. For long-term space exploration, a reliable food supply is essential, necessitating the production of food in space. To produce food in space, the unique conditions of the space environment must be considered. These conditions include gravity, space radiation, and the atmosphere. Among these factors, we aim to investigate the response of chlorophyll to fluorescence and plant growth in relation to different gravitational conditions. This device most commonly used to counteract gravity is called a clinostate. The principle behind this device is to offset the vector of value of gravity through rotation. As the distance from the rotating center axis increase, the effects of angular velocity increase, resulting in greater counteraction of gravity. So, aim to study the effects of different gravity level determined by varying distance on planes and observe the effects of the force applied to them. This is my objective. First one is to investigate the effects of different gravitational levels on photosynthesis. Second one is to assess the growth status and health of the plant. This experiment was conducted in the plant factory installed at Gyeongsang National University, and give LED wavelengths is setting about 450 nanometer and 660 nanometer. The LED turn on 8 a.m. to 6 p.m. The group were contour center 6 cm, distance of center to 6 centimeter, 12 centimeter, have 4 groups and with 5 plants in each group. And the water amounts and pot weight, temperature, and humidity were kept constant. The light intensity was a maximum of 7,000 lux and a minimum of 5,500, with the control and center group receiving 4,000 lux. Data were collected from 3 plants in each group during 9 days. Data collection was conducted using the OS30P for chlorophyll fluorescence, vernier calipers for leaf length and width, and the SPAD 502 for chlorophyll contents. The average value for each group were calculated and compared across the groups. And I choose the type of plants, lettuce cartilage type. The major chlorophyll to fluorescence values are presented with this value, measured during this period using the 5 values above. And the upper one is baseline state and initial stress response state, intermediate stress response, late stress response, and last one is maximum fluorescence state. This is the chlorophyllorans graph during one day using 4 groups. In early stage, center and control groups maintain high fluorescence intensity with no impact on photosynthesis efficiency. At 6, a decrease in inflorescence intensity was observed along with the decline in photosynthesis efficiency, but 12 centimeter, the fluorescence intensity remained consistently low, indicating that strong gravitational stimuli hydrate photosynthesis. And the middle stage, control and center groups maintain stable, but 6 centimeter fluorescence recovers and reaches a level similar to the control and center group. 12 centimeter fluorescence intensity remained low and did not recover. In the later stage, control and center maintained high fluorescence. At 6 centimeter fluorescence intensity was similar to that of the control and center group, indicating adaptation. 12 centimeter fluorescence remained low, and the decline in photosynthetic efficiency persisted. And the graph represents the mean and standard deviation and validates was testing through a one-way ANOVA analysis. If the latter are the same, it indicating no significant difference, while different letters indicate a statistically significant difference. Regardless one of distance from the rotation axis, the planes showed similar growth patterns. This suggests that after the initial growth pace, leaf length was not significantly influenced by the rotation conditions. These findings indicated that leaf length grows stably, unaffected by the distance from the rotation axis. This is the leaf-wide graph. The control and center groups exhibited similar results in leaf width, indicating stable growth. Under the 6 cm and 12 cm conditions, a reduction in leaf width was observed due to the rotational effect, with the 12 conditions showing the greatest reduction. These findings suggest the rotational conditions and the distance from the rotation axis influences leaf width. And the last one is SPAD graph. The control group exhibited lower SPAD values, reflecting the normal gravity environment. The 6 cm and 12 cm condition shows higher SPAD values, with the 12 cm condition displaying more active chlorophyll synthesis. Over time, the SPAD value varied between the early and late stages, but became less distinct during the middle stage. Chlorophyll fluorescence in early stage was little difference in value among the groups, but the mid stage have difference began to emerge, particularly between the K and I. In the later stage, K and I step difference diminished, while the P step difference become more distinct. The control group show lower values, indicating no stress. The plant growth leaf length remained stable regardless of the distance from the rotational axis. Leaf width decreased with increasing distance from the rotational axis, showing the strongest reduction at 12 cm. SPAD value were higher or greater distance from the rotational axis with the highest values observed at 12 centimeter, indicating enhanced chlorophyll synthesis. Conclusions. Overall, there are differences between the gravity states, but they are not significant enough to clearly noticeable. Since the Clino states counteracting effects various depending on the RPM and the distance from the rotation axis, so next experiment, I will adjust the setting and experiment again. Thank you for listening.
Thank you for your presentation. If anyone has question, you can ask.
부족했던 것 같습니다.
Thank you for your presentation. This concludes in the seminar section. Thank you for all present and attention for your participation. We will now take 10 minutes for break. After 10 minutes, we come back to this room. Thank you.
Good. Good afternoon, everyone. My name is Mok, and I am serving as the chairwoman to manage the time for this final presentation section. The list of presenters is as following. บาชินอยโฮดานุนัยปิติจาโยโกะยามะไอชลิตาแก้วทาสี จองฮูคุก and ธิดาพรสุวรรณศรี To ensure that everyone can use daytime efficiency and in accordance with the schedule, I would like to outline the timing guideline. Each presenter will have 20 minutes, including the Q&A section. A bell will ring when there are 2 minutes remaining to remind the presenter to conclude. When the time is up, the bell will ring to indicate the end of the presentation. Next, I would like to invite Bashino Yoya to begin the presentation.
Okay, hello everyone. Thank you for joining. Today I will be presenting a study conducted at Kochi University in 2023. It focused on microplastic pollution from agricultural areas, particularly from paddy fields and drainage systems. Although I wasn't directly involved in the research, I'll do my best to convey the important findings. Okay. Microplastics are a growing environmental problem, polluting not only our oceans, but also soil and agricultural ecosystems. In fact, microplastic can absorb harmful chemicals like BPA and NP, making them even more dangerous. These studies specifically investigated microplastics pollution originating from agricultural activities, a source often overlooked. Figure 1 is graph illustrates the cumulative trends in plastic waste generating and its disposal methods from 1950 to projection for 2050. The aim of this study was threefold. 1, to investigate the runoff of microplastic from agricultural drainage and paddy fields. 2, to quantify the levels of contamination. 3, to propose effective countermeasures to reduce this pollution. The main culprit under investigation: coated fertilizers, which are widely used in agriculture. Figure 2 is a picture of the paddy field at Kochi University. Coated fertilizers are a type of controlled release fertilizer. They are designed to efficiently deliver nutrients to crops over time, reducing the need for repeated applications. Figure 3 is about how coated fertilizer works. Coated fertilizers function by absorbing water, which dissolves the fertilizer components inside. Once the coating breaks down, the dissolved fertilizer is released. However, the degradation of the coating is influenced by factors such as time and temperatures. Due to these characteristics, undissolved coating often flow into water system during paddy rice cultivation, causing environmental concerns. Essentially, they feed plants and pollute the environment at the same time. This study was conducted at Kochi University campus, focusing on agricultural drainage and paddy fields. Samples were collected during the rainy season in June and July 2023, which corresponds to the rice cultivation period. Figure 5 shows
the process of collecting plastic waste from a drainage channel. Figure 6 presents the actual collected samples where the orange particles represent coated filterizers. We used acid treatment to process the samples and FTIR spectroscopy to identify and analyze the microplastics. Microplastics were detected in all drainage samples and paddy soil. Table 1 provides a detailed breakdown of the microplastic quantity and weight detected in drainage water. The results show that a total of 369 particles were found, with fertilizer coating makes up the majority at 352 particles, 95.4% of the total count. The weight of fertilizer coating was 1.5 gram, accounting for most of the total weight of 1.7 gram. This highlights the significant contribution of coated fertilizer to microplastic pollution in drainage water. Table 2 summarizes the quantity and weight of microplastics found in paddy soil samples. A total of 80 fertilizer coating particles were detected with a combined weight of 0.2 gram. These findings suggested that coated fertilizer not only pollute water system but also persist in accumulation and persist in soil, indicating long-term environmental accumulation and potential risk to agriculture ecosystems. Based on the data, the estimated annual runoff microplastics from 4.5 hectares of paddy fields was over 35,000 particles. For the end city in Kochi, the total annual runoff was projected to exceed 18 million particles. This highlights the significant contribution of agricultural activities to microplastic pollution. In summary, coated fertilizers are a significant source of microplastic pollution in agriculture. These particles persist in water and soil, leading to long-term environmental risks. Immediate action is needed to this issue, starting with the proposed countermeasures. Together, we can tackle microplastic pollution for a cleaner and safe future. In conclusion, plastic might stick around for 500 years, but with your help, this presentation won't last nearly as long. Thank you.
Thank you for your presentation. How do you measure microplastic in your project?
In this project, could you see the net in this figure 5?
You collect a sample only in the water,
This
right?
This net size can collect bigger than 5 micrometer plastics. So if we collect by this, we already know that that is bigger than 5 micrometers. Yeah.
Okay, thank you.
Thank you so much.
I would like to know about two things. The first thing is, why do you think only the coated fertilizer is the only source for microplastic for the paddy field?
This is not only source. We thought there are a lot of sources, but one of the reason of pollution by microplastic is this coated filterizer. And from now on, I will do another research for the reason of microplastic.
Okay, I would like to know about what is the action for mitigate the microplastic for the paddy field. What do you think the immediate action?
Immediate action.
That you mentioned in the conclusion part. What do you think? What is like action that you want to do
about this research?
For mitigate the microplastics?
To decrease
The conclusion part. Can you go to the conclusion part, please? Yeah, this the point. The last point is immediate action is required. What is the action you want to require?
For example, not using so many coated fertilizers and using more natural fertilizer like from
Okay, thank you.
Thank you
so much.
Sorry.
Thank you for the presentations. Basically, my question is like, why do we coat the fertilizers with the plastics in first place?
Because about this slide, right? If we use coated filterizer, it affected slowly, so you don't have to put in the soil so many times. So it would more easier for farmer.
Like regarding this, there is any government-related policy such that this threshold of microplastic pollutions is allowed, and such any policies is there?
Sorry, I don't know.
Okay, thank you.
Thank you.
Thank you for your presentation. Next, I would like to invite Danunai Pitija.
Good morning, everyone. My name is Danunai Pitija, Master Degree from Department of Conservation, Faculty of Forestry, Kochi University. Today, we present scientific thesis topic on microplastic prediction use hydrological model under climate change scenario at Upper Ping watershed. The microplastic problem has become increasingly so I add improperly discarded everyday plastic break down into microplastic microscopic particle. This microplastic can easily contaminate very organisms, including the turtle, shellfish, fish, or the shrimp, as well as the environmental. The particular aquatic system. The rainfall washed this microplastic into water body, which out to increasing frequency, pattern, or and intensity of extreme weather event. The 21 model has been used to accurately simulate and predict microplastic level in the water body due to its high reliability. There are the objectives as follows. The first, to study the microplastic concentration in the upper Ping watershed. And the second, to predict the microplastic concentration under the climate change scenario in the upper Ping watershed using hydrological model. The study area consists of the 66% for the forest, 24% agriculture, and 7% urban. Will has a population of over 800,000 and nearly 2 million tourists. The high population density increase the likelihood to microplastic contaminate in the environmental. The sample collection is used equipment like the sample bottom, and collected sample were then subject the laboratory analysis used instruments such as filter papers, stereo microscope, oven, and data analysis was performed using the QGIS and made by the HI software. The process, the diagram, right? The second is the data collection and the take to input data for the My 2021 model and the summary have the microplastic concentration. Right? The data collection will sample will collected using the gap sample at the Three Royal Irrigation Department Station from the January to December 2023. 1,000 milliliter for surface water sample will be collected at each sampling event. Another and in the laboratory and treat hydrogen peroxide and the sodium chloride. Were added to the sample to degraded organic matter and separate suspended solid respectively. The sample were then filtered and analyzed for microplastic under the stereo microscope and obtain data to the input into the My 21 to simulate microplastic transport. There's something like that. It is the result and discuss 2 seconds for follow the objective is result one. The first result is microplastic concentration, and second prediction of microplastic under climate change. The results one, the study found the microplastic concentration in the Upper Ping River in 2023 is very difficult. A different sampling station, station P.75 has a higher average concentration at the 38.75 particle per liter, followed by station P1 and P67 with 31.99 and 28.95 particle per liter, respectively. In addition, fiber microplastic were the most abundant type at the all station, followed by the fragment. However, the result indicate that microplastic level in the Upper Ping River are the higher compared to the เจ้าพระยา บางปะกง ท่าจีน Rayong River, likely due to the different in the sampling method, lack of wastewater treatment for loudly, and the use of plastic products such as bag, bottle, agriculture chemical, and additional and activity during the dry season contribute to increase fiber release of causing into the water body. Yeah. Right. In the second result and discuss to the result will be the project of the microplastic amount of microplastic under the climate change scenario in 2028 as follow. SFP 245 scenario found 11,897 pieces of accumulated microplastic per liter. SFP 750 scenario found 11,887 pieces accumulated microplastic per liter, and SFP 585 scenario found 11,827 pieces of accumulated microplastic per liter. When the statistic relationship what found the amount of microplastic not significantly different of the current amount in indicating that other factor beside climate, such as a plastic consumption at the waste management may play an important role in determining an amount of microplastic in the future. However, the overall amount of microplastic trend is increased. In the conclusion, in 2023, the amount of microplastic record at the station was the follow: station P1, 32.1.7 pieces per liter, 20 station P65, 28.25 pieces per liter, station P75, 38.59 per liter, piece per liter. Prediction amount of microplastic to 2028 under different climate change scenario show the increasing trend in the microplastic abundance, but are not significantly different. But plastic use and waste management factor are appearing to have a more significant impact than climate change alone. Thank you.
Thank you for your presentation. Could you show me the conclusion one page?
Yeah.
Before this. This one, thank you. What do you think is the reason for the significant difference in the monthly figures of microplastics? The number of microplastic is so different. Like
the reason of the different in this table is the different table for the different concentration microplastic of month this here because the rainfall drop in the area, and the water to move accurate move upland to lowland this low in dry season. For the accurate for the non accurate it is more concentration, but to the wet season it different to the dry season, but I cannot to detect microplastic is how to different.
Okay, thank you.
Thank you for your presentation. I have two questions. The one thing is, I want to know the global
Characteristic or
climate change scenario, and why is the difference? The three global climate change scenario you mentioned in your presentation.
Yeah, my presentation, I don't explain the scenario because the the scenario is I focus the rainfall only. I'm drop down to the data set in the worldwide and drop down to the data and input to my 21 and have this out this there, but detail of the scenario 245 370 585 different scenario. Precipitation is not rain more. This 245 is the same like 585, but 375 is higher. This more this is true. But I don't know for explain 370 same, but
Okay, thank you.
Thank you for your presentation. Next, I would like to invite Yakoyama.
Hello everyone. My name is Yokoyama from Kochi University. I will be presenting a slide titled Follow-up Survey of Damage to Surface Coating Materials Applied to Concrete Waterways. Currently, Japan's agricultural irrigation facilities were constructed intensively between 1955 and 1972, and as a result, they are all aging at the same time. As this progresses, an increasing number of them are due for renewal. Blue parts in graph on right represents those that have already exceeded their useful life, accounting for 53% of total. Orange parts represent those that will exceed their useful life in the next 10 years, which together accounts for 69% of total. However, Building new facilities requires enormous amounts of money, so it has become a social issue to take measures to extend the lifespan of existing facilities by appropriately repairing and reinforcing them, and to reduce life cycle cost. Life cycle cost is total cost incurred from construction to demolition of a structure. By the way, my house has long since exceeded its useful life and is in urgent need of repairs. In order to consider design and construction of life extension measures, it is essential to organize basic facility information based on existing materials and to confirm current state of facility through field researches to supplement missing information. Therefore, in this research, I will confirm current state of facilities for the purpose of data collection. Specifically, I will research occurrence and causes of deformation of concrete waterways that have been in service for a long time. Concrete waterway targeted in this research was constructed more than 40 years ago and was repaired using 40 different methods between 2005 and 2008. However, deformations such as cracks occurred soon after construction. Here, I will explain repair method that was used on this waterway. It is a surface coating method. Surface coating method, as shown in illustration on right, is a method of coating concrete to block deterioration factors, such as moisture and salt, that penetrate into interior of concrete from surface, thereby preventing deterioration of concrete. This is most common repair method. The method used in this waterway is classified into 5 types: inorganic type, organic type, seed type, panel type, and impregnant type. 4 types of construction methods surrounded by orange frames are constructed using mechanisms shown in illustration on right. Inorganic type is coating materials that use inorganic materials as main component. A typical example is polymer cement mortar. Organic type is coating materials that use organic resin as main components. Typical examples are epoxy resin and polyurethane resin. Panel and seed types are construction methods that cover surfaces by installing panels or seeds as one of components of coating. Impregnation material type enclosed in a light blue frame is different from the other 4 methods. First, an impregnating material is applied to surface of concrete, where it reacts with internal components and fills internal voids. This modifies and densifies structure of surface layer of concrete, making it possible to prevent intrusion of deterioration factors. Then concrete is covered with a coating material. This also improves quality of coating material. Next, I will explain a method of research. Main types of deformation researched this time are cracking, lifting, and peeling. Check presence and degree of these deformations. Research method is visual inspection and hammering inspection. During visual inspection, I visually check exterior appearance and check for cracks. For cracks, width and length of cracks are recorded using a crack scale like one in photo. During hammering inspection, I use an inspection hammer like one shown in photo to check for any lifting or peeling. Hit concrete with a hammer and check for presence based on difference in sound. Then, where any lifting or peeling is found, the area is marked and its size is measured. Now, let me explain early deformation that I mentioned earlier. This tape shows results of a research conducted in 2008. For each construction method type, number of constructions carried out, number of deformations that have occurred, and ratio are listed. Types of deformations and methods used were same as this time. Only seed type has no deformation, and the other types have many deformations. In total, deformations occurred in 26 out of 40 construction methods, making ratio 65%. Most common deformation was cracking, followed by lifting and peeling. Additionally, this 2008 research was third, and number of deformations had increased compared to previous two research. From this, it can be predicted that number of deformations will continue to increase after 2008, and degree of deformation will become more severe. Finally, organize dates and make further comparisons. By comparing data obtained in this research with data from 2008, I will confirm how much deterioration has progressed in 16 years since 2008. I will also compare each construction method category, find out how much difference there is in degree of deterioration depending on type of construction methods, and consider which construction method is most suitable or not suitable for researched waterway. This concludes my presentation. Thank you for your attention.
Please, if anyone had any question.
The question is, what is the best surface coating method and why?
Sorry, one more.
What is the best surface coating method?
Yeah.
And why?
Why? Why?
Yes, and
okay.
Why?
Japan's waterway. Japan's waterway most common repair method is coating method. Okay. Most common.
Thank you for your presentation. Next, I would like to invite Thidapon Suwarnasi.
Hello, my name is Thidapon Suwarnasi, and my research title Systemic Prediction using the Invest model under global climate change in the Hoi Kasiao sub watershed, Suphanburi province. The issue of soil erosion in the Hoi Kasiao watershed, Suphanburi province, is a significant concern, particularly in area dominated by monoculture farming, which affect the land's ability to retain soil. This study investigates the potential for soil erosion based on three factors, such as rainfall to determine its relationship with soil loss from the area. The study used data from 2021 best year and apply the invest sedimentary radio model to predict future soil erosion. Under changing rainfall conditions, this prediction and are based on climate change scenario from CIMIFIC. Using the global climate model MPI ESM 12SR, including SSP 245, SSP G70, and SSP 585 scenario for the period 2021 to 2040. Furthermore, the economic value of soil loss in the Hoi Kasiao watershed is assessed to support appropriate land management, planning, and sustainable development. The objective of this study is assess the quantity of sediment in 2071 sediment prediction under global climate change and evaluate economic value. The Hoi Kasiao watershed is located in Suphanburi province in the central region of Thailand. The majority of the terrain is flat, with the upper part of the watershed consisting of mountain range. The watershed converts and are 1.1 million right. The elevation range from 6 to 1,432 meters above sea level. The area reserve and average annual rainfall of 988.1 millimeter. Land cover in 2021, the majority of land use is for agriculture, accounting for 60.5% of the area, followed by forest area accounting for 29.2% of the area, and urban and rooting up land accounting for 5.3% of the area. In the study, the research methodology will utilize software tools for geographic and statistical data analysis, including one geographic information system software through Microsoft Excel, three Invest software with the following import parameter. Boundary of the Hoi Kasia watershed, digital elevation model, rainfall erosivity index factor, consists of precipitation of 2021 and precipitation scenario SSP, soil erodibility factor, land use land cover, biophysical table, consists of land use code, conservation practice factor, and cropping management factor. For accumulate Mortality K parameter, Mortality IC parameter แล้วก็ Max SDR value. The difference in the R factor between each scenario. Subsequently, the parameters are input into the Invest model to calculate soil erosion, which is determined using the universal soil loss equation. The model also calculates sediment export and sediment deposit based on the aforementioned equation using the following results. In 2021, the total soil loss was 13 million tons per year, while the total soil loss for all three scenarios was 7 million tons per year. In 2021, the sediment export was 1.3 million tons per year, while the sediment export for all 3,000 was 0.7 million tons per year. In 2021, the sediment deposit was 1.1 million tons per year, while the sediment deposit for all three scenarios was 0.6 million tons per year. The study found that rainfall erosivity factor significantly contribute to increased soil erosion with the highest occurrence on highland area. When you are when evaluating the economic value of soil loss in 2021 is what estimated at 2.3 million baht, and for three scenarios, the estimate value was approximately 1.3 million baht. I can caution that the scenario with the highest total soil loss ton per year is 2021, followed by SSP 3770, SSP 245, and SSP 585, with soil loss amounts of 7.6, 7.5 million tons per year, respectively. When converted to the economic value of soil loss, the amount are approximately 2.3, 1.33, 1.31, 1.3 million baht, respectively. Thank you.
If anyone had any question, please ask.
Hello, good afternoon. My name is Malvin. I'm a new student here. Thank you for your presentation. I just want to ask, in your watershed, what type of land use contributes significantly to soil erosion or soil loss process?
Agriculture, because agriculture on have erosion length high.
Yeah, thank you.
Thank you for your presentation. Is a time out.
Sorry for interrupt. In the conclusion on the scenario, what is SSP 370 and the others stand for?
Shared economic pathway. level carbon dioxide
Is the level of carbon dioxide? What is the SP means?
Thank you for your presentation. Next, I would like to invite Jong Hoo Kook.
Hello everyone. Good afternoon. So I'm Chung Hoo Kook and I'm in Gyeongsang National University. And my supervisor is Professor Hyun-tae Kim. And the topic of my research is correlation study of chlorophyll content and environmental variable in strawberry. So I want to know relationship between strawberry chlorophyll content and greenhouse environmental variables. So before going to presentation, I prepared some my photos. So this one is me. So last year I went to Kochi University, and this year January I also went this Kasesa University. So looks like a little different, but this is me. So maybe someone now remember me. Then these are contents of my presentation. So recently, this graph is 2020 export performance of Korean strawberries export. So this graph shows rapidly growth of strawberry export values is 2020. So as of 2023, Korea's strawberry export value is 71.1 million US dollars, and Koreans export volumes are steadily increasing, and the Korea's export value target is $100 million by 2025. So recently, strawberry is a very popular and very influenced plant. And strawberry have a little different cultivating, growing method. So though maybe someone thinking about strawberry from seed, from seed to growing, but normally commercial farm case using only daughter plant. So this right picture. So right side is have mother plant, and according to using runners, and then they make daughter plant. So only using this daughter plant and transplanting only these seedlings. So a little different ways, and strawberries. Yes, different ways. The reason why they not using seed means use daughter plants for stable and rapid harvest and preservation of genetic characteristics. So after transplanting, we we have to make appropriate environment, and managing growth after transplanting is very important. So there is a need to identify appropriate environmental factors, and I want to confirm this through chlorophyll content. So before I already said I want to know relationship between chlorophyll content and environmental factors. So this research I used 5 variables for. So first one is temperature, humidity, and CO2 concentration, and illuminance, and I used the chlorophyll content. So this was the research objectives is to find the relationship between environmental variables and chlorophyll content, and second one is to find appropriate environmental variables for prediction of chlorophyll content. So the experiment was conducted in a commercial greenhouse in South Korea, and the data collection period is from December 20 to March 15. So 86 days I collected this data, and this greenhouse size is width is 8.5 meter and length is 95 meters, so almost 100 meters. These little big commercial farms, and the side height is 1.8 meter and normal height is 3.5 meters. So I collected environmental data using these sensors. So first one is CO2 and temperature and humidity sensors, and third one is light meter. So I installed these first CO2 sensors with near root zones, and second light meter case, light meter installed minimum height for not obscured by leaves. So yes, so and this chlorophyll meter is name is SPAD meters, and from Konica Minolta in Japan, and I manually collected this chlorophyll meter and chlorophyll content data using these 3 points. And this environmental data case, every minute I collected data, and this manually chlorophyll content data I collected every week, and using these 5 variables, and then I combined, doing this process, and then I did correlation analysis. So result of my research, and this research have 2 cultivators. So you guys already heard Kumsil and Seolhyang. So I used the 2 varieties, and left one is Seolhyang and right one is Kumsil. So I have 2 varieties data, and from 2023 December 20 to 2024 March 14th. And this one is representative data of 2 cultivars data. So this minimum and maximum is a little confirmed, but I want to why I prepared this graph. The reason why median and average case. So normally we are using average case, but like left to downside, illuminance graph shows max is very high, but average is low, and median case a little more lower. So this have only maximum and minimum is not enough, and average also a little not fit this research. And this one is a correlation heat map. So I used the Spearman correlation analysis. So I already explained I want to know relationship between chlorophyll contents and other environmental factors, but these 5 lines don't have correlations with the chlorophyll content, and little air temperature and relative humidity and lux case have a little small correlation, but Kumsil and Seohyang or both cases also don't have chlorophyll content correlations. So this result is, this one is not finished the experiment, but result is only a weak correlation observed among temperature and relative humidity and illuminance. And chlorophyll content does not show significant correlations with other environmental variables. So this discussion part is, but yes, it is guessed that there is an indirect relationship through causality rather than a direct correlation. So I think, yes, this is my opinions. So now the current study utilized data collected from commercial farms. So this one is only have, only have normal group data. So these have lack of an experimental groups and control variables data is don't have. So maybe this one is we cannot comparison other critical data. And second one is using data from time period when photosynthesis. So chlorophyll contents have photosynthesis case need daytime and light case, but I used only 24 hours data, so maybe I'm using data from time period when photosynthesis is most active, or altering data pre-processing method could maybe potentially yield different results. So, and third one is incorporating crop growth data or direct environmental factors such as soil nutrient level, or could provide a deeper insight into the relationship. So now I just using environmental data and inside chlorophyll content, but maybe this middle side have some crop growth data like leaf length or leaf width or crown thickness, like that. And this soil nutrient levels case also maybe directly affect to root zone. So maybe these, yes. So so this study was conducted to investigate the correlation between chlorophyll content in strawberry leaves and greenhouse environmental variables, but the analysis revealed correlation among the only environmental variables, and no significant relationship with chlorophyll content. So I already explained the discussion part. So future research incorporating additional variables like image data or crop growth data or soil nutrient solution levels, like that, and employing advanced analytical methods may help uncover the relationship with chlorophyll content. Yes, thanks for your time.
Please, there is still enough time for one question. Yes, and thank you for your presentation. Next, I would like invite Charlita แก้วทาสี
ค Good evening, everyone. Today I will present about forecasting scheme for using the inverse model under climate change in the ห้วยกระเสียว South Watershed สุพรรณบุรี Province ค่ะ Introduction The ห้วยกระเสียว stream are main tributary of the Tajin River in Suphanburi often cause floods during heavy rain due to its steep slope and large catchment area of about 1,220 square kilometers. Flood regularly damage farmland while during dry periods there isn't enough water for farming. Deforestation works this problem. This study focused on predicting waterfall in the ห้วยกระเสียว sub-basin using the inverse model. Considering the effect of climate change and land use change, the goal is to help prepare for floods and drought and understand the economic value of water under changing conditions. Objective of research: 1. To assess the average rainfall over the past 15 years. This is baseline periods. 2. To forecast rainfall under climate change scenario based on CMIP 6. 3. To evaluate to economic value of rainfall under changing climate conditions. Material: 1. Annual average rainfall and rainfall data for the past 15 years for 2008 to 2023. 2. Data used for running the model. I will use digital evaluation model, precipitation, different evapotranspiration, land use, land cover, soil depth. 3. Mapping software. I use ArcMap. For modeling software is inverse model. Study area. The study area is located in upper parts of the ห้วยกระเสียว sub-basin, covering 1,904.2 square kilometers. Next method, precipitation. I will collect from the annual average rainfall data in millimeter, collect from 2008 to 2023 as 6 rainfall monitoring station located within the watershed. The data is then converted into the raster format using ArcMap software, employing the inverse distance weighting interpolation method. Evapotranspiration. The evapotranspiration data is shown for CGIAR CSI consortium for special information. There are high-resolution global raster climate data sets that provide information related to plant transpiration, water evaporation, and rainfall scarcity. Affection plant growth. The data is represented as global map. Loose resting layer depth. The map shows the depth where roots grow. The goal is significantly recede due to physical or chemical soil property. The soil used in the model is measured in millimeter. In this study, the area is obtained from the ISRIC data have using ISRIC soil kit 250 meters. Plant available water capacity. Plant available capacity refer to soil ability to hold water against gravity with soil particles retaining water through accretion force. In this study, pH AWC data is sourced from global soil kit 2017 AWC. In global spatial data set show the amount of water in the soil that plant can absorb based on soil property in each area. Land use and land cover data are obtained from GIS vector data for 2020 and 2021. Using level 3 classification, the vector data is kept to match the Hue Kaseal watershed boundary. The watershed contains 132 land use types. The vector data is then converted to data format using the polygon to raster to in ArcMap. Ordered by the core land use LU code column. Biophysical table. The biophysical table contains biological parameters for each LULC category. Every value in LULC raster must have corresponding data in this table. The table is created in Microsoft Excel with the following column: land use, LU close, vegetation cover index, root depth, evapotranspiration coefficient. And in seasonal factor, represent geological characteristics and the seasonal distribution of rainfall is typically ranked from 1 to 30 and is empirical constant, sometimes called the seasonal factor, reflecting local rainfall pattern and addition geological traces such is positively correlates with the number of heavy rain days for this study such it calculated based on the number of days with rainfall exceeding 35 mm per month. Following the method of the formula followed by the result precipitation. The 15-year average rainfall has a minimum value of 1,103.24 mm and maximum value of 1,285.4 mm. In the SSP 245 scenario, rainfall range from a minimum of 937 mm to maximum of 1,263 mm. In the SSP T70 scenario, rainfall range from a minimum of 885 mm to a maximum of 1,189 mm. In the SSP 585 scenario, rainfall range from a minimum of 920 mm to a maximum of 1,242 mm. Evapotranspiration, the higher average evapotranspiration, the maximum value of 1,228.89 mm. In SSP 245, maximum of 1,204.83 mm. SSP 370, maximum of 1,148.51. In SSP 585 scenario, maximum of 1,182.9 mm. Water yield In the 15-year average steam fall volume as predicted by the model is 157.44 million cubic meter. Its result demonstrated the model capability to value the steam fall potential of the target area. Forecasting of water yield. Under different scenarios, the steam fall and water yield as follows. SSP 245 scenario, steam fall volume 236.37 million cubic meter. Water yield is 124.13 millimeter. SSP T70 scenario, steam fall volume 190.65 million cubic meter. Water yield 100.12 millimeter. SSP 5F5 scenario, steam fall volume 218.87 million cubic meter. Water yield 114.94 millimeter. Where valuation, the economic value of steam fall under different climate change scenario can be assessed by using the current raw water sale price in Thailand in the central regions and surrounding area. The average price for raw water in 10 baht per cubic meter. This price will be used to estimate the value of future steam fall resulting from climate change. Thank you.
Thank you. Please, there is still enough time for one question.
Thank you for the good presentations. I have only one question regarding the different scenario. The estimations is different. What is the basic difference between the scenario like this SSP one? The predictions has been done on the basis of SSP 235 or something number was there. So what is the difference between each scenario?
It's different about climate change and economy growth.
Okay, thank you.
Thank you.
Thank you for your presentation.
Thank you.
That concludes this seminar session. Thank you to our presenter and participants. I now invite Professor Nalumon to continue. Thank you.
Okay, so everyone, so right now we are become the last section, right? Yeah, so are you tired? So sleepy? It looks like very sleepy, right? So, but right now, yeah, for the last section, so become to like very relaxing. So that's why I would like to presentation, not presenter that you have present. Who's not presenter for today? So please have you have. Yeah, so then so we have to time for the self introduction for all of you. Yeah, so because we would like to all of you to like know each other. Okay, so who's not presenter today? So please come in the stage for all. For all. Yeah, I think so. We have around more than 10 students here, right? Okay, so we are here. That's okay, right? Okay, so first from, okay, let's start from you, I think.
Good afternoon. My name is Rosmi Setia from India, Assam, India. I am PhD student in Balaialankon Rajabhat University under the royal patronage. I am thankful to the Kasasat University that I get the opportunity to join this seminar. So thank you all of you.
Thank you. Yeah, so that's why we still have a new friends like a new friend from other university. It's not Kasetsat University, from Valaialankon University, right?
Yes,
Yeah.
yes.
Okay, a master student, right?
I'm a PhD student.
PhD, oh, so sorry. Okay, so next.
Hello everyone. Myself, Aiseng Noborua from Assam, Northeast India. I am also second semester PhD student at Balaialankon Rajabhat University. I'm very thankful to Kasetsat University giving us the great opportunity to stay and learn from this conference. Thank you very much.
Yeah. Okay, who is next? Who is next? Okay, so we move here from the Thai student. Yeah.
Hello, my name is Patompong Khayai Keo. Nickname is Got, G-O-T, not D. I'm the master student from here, Kasetsat University, Faculty of Forestry. Yes, I'm a new master student. Thank you.
Thank you. Okay, so move to next. Yeah.
Hello, everyone. My name is Pongsri Pasi. My nickname Mick. I am a master student in a Faculty of Forestry in the University, Kasetsat University. Thank you.
Hello everyone, my name is Sunri Kwan Keo. You can call me Mok. I'm a granted first year master. Study in Faculty of Forestry, Watershed Management in Kasetsat. Thank you.
Hi, my name is Tauchana Nawasanchai. I'm first year master student from Faculty of Forestry, Kasetsat University. Thank you.
Hello everyone, my name is Vorayos Sawangchom. My nickname is Yos. I am master degree student in Faculty of Forestry. My field watershed and environmental management. Thank you.
Okay, thank you. Okay, so let's move from to Thai student to they are undergrad student, right? Okay, let's start.
Hello, my name is Kitipong Hamalo. My nickname is Pansip. I am study third year bachelor student from Department of Silviculture, Faculty of Forestry. Thank you.
Okay, so we have three students here at first.
Hi, I'm Kalima Supung Sang, but you can call me Kim. I'm student the Faculty of Forestry, majoring in watershed and environmental management. My project is about the water footprint of rubber tree in the Wang Wiset Forestry Plantation area, Tang Poet. Thank you.
Hi, my name is Chitashia Thongbo. My nickname is Bo. Year 4 bachelor degree, and I'm from a science department of science faculty. Thank you.
Good afternoon to everyone. My name is Acharapon Kasemsot, and you can call me Nam. Now I'm studying in year 4 bachelor students and in Faculty of Science, major of Earth Science and Geology.
Okay, so the next we have the one Philippines here.
Sawadee Kap. Yeah, good afternoon, everyone. My name is Malvin Bigueras. You can call me Malvin. I'm from the Philippines. I'm a PhD student for the Sustainable Land Use and Natural Resources Management program of the graduate school. I would like to thank this opportunity also to thank Kasetsart Arts University for inviting me here. I'm happy to see new faces from different universities from Japan and Korea. Kapun Kap.
Yeah, so, yeah, thank you so much. And also from the last group, yeah, so students from Koreans from Gyeongsang National University. Okay, who's it? Oh, really? Oh. Okay. Okay, so please. Yeah, yes, so please go on stage. You have, do you have some like presentation, right? So. Shut down the microphone, please.
Good afternoon. My name is Jaemin Park, and I am from the Department of Bioindustrial Machinery Engineering at Gyeongsang National University. Today, I will introduce about what I am studying as a member of my university's club, Robo Club. The outline of my presentation is as follows. Technology development goals, technology development details, conclusion and expected outcomes, and future research direction. Let's start with technology development goals. I believe when we developing technology, I believe understanding the why is the most important aspect. South Korea faces a significant shortage of agricultural labor and declining productivity, making automation in agriculture essential. To address these challenges, smart agriculture and agricultural robots are rapidly advancing, offering innovative solutions for sustainable farming. And how can I contribute with this problem is implementation of an agricultural robot that performs line tracing and autonomous driving, alertness detection and counting, and obstacle avoidance tasks. We base our work on these types of robots, developing programs tailored to specific objectives. If necessary, we also modify the designs using 3D printers to suit their intended purpose. I'm going to explain about line tracing. Robots equipped with precision navigation for efficient movement in the farming environment, like plant factory. We adjust P and I and D values according to the robot's weight, surrounding, and other conditions to ensure it moves as intended. Our goal is to perform the line tracing using the robot's camera with HSV values. Next, we're studying about autonomous driving, real-time detection and avoidance of obstacles to ensure seamless operation in dynamic agriculture settings. For this feature, we use LiDAR sensors, enabling the robot to retrieve mapped data and perform autonomous driving without colliding with obstacles. Next, fruit recognition. We use YOLO version 5. We aim to implement an algorithm capable of distinguish between mature and immature fruits and counting them. In the future, we plan to upgrade to a higher version of YOLO for enhanced performance. Next, conclusion and expected outcomes. Obstacle avoidance, detecting obstacle and people to prevent collisions and ensure safety. Next, efficiency and productivity. Address the issue of labor shortage in agriculture and improve work efficiency through automation. Next, smart agriculture. Technologies to establish a sustainable agriculture environment. Next, future research direction. Currently, the GES Nano's performance has certain limitation due to its low computation power. Delays occur during real-time operations, restricting its efficiency. To address this issue, I plan to run the ROS master node on my desktop computer and use portfolio to connect it with the GES Nano. This approach will offload computational tasks to the desktop, effectively resolving the performance bottlenecks. Thank you for listening.
In the next student, yeah. Thank you, Jamin Park, right?
Hello, my name is Lee Soo-jung, and I am a third-year undergraduate student majoring in bioindustrial machinery engineering at Gyeongsang National University. I would like to present on the future of agriculture. I will explain the table of contents. First, I will present the current problems of agriculture. Next, innovative technologies for future agriculture. And finally, the prospects for future agriculture. First, I will present the current problems of agriculture. Representative problems include climate change, natural disasters, labor shortages and aging, and environmental pollution. The first problem is climate change and natural disasters. The image on the left shows the damage caused by drought, and the image on the right shows the damage caused by a typhoon. The second problem is the shortage of labor and aging population. Unlike in the past, the rural society now faces a significant decrease in the available workforce. The final problem is environmental pollution, leading to serious environmental pollution because agricultural waste is currently being generated. Next, I will present innovative technologies for the future of agriculture. Innovative technologies for the future of agriculture include smart farming technologies using coding, automation technologies using drones, climate change adaptation strategies. If you look at the table, the technologies include smart farming technologies, drone and automation technologies, and sustainable agriculture technologies. The measures include AI and big data analysis, drones and automation, sustainable agricultural technologies. Finally, I will present the outlook for the future of agriculture. On the left side, you can see a table showing the outlook for future agricultural technologies as indicated in the table. The usage of these technologies is gradually increasing each year. On the right side, there is a table showing the application areas of future agricultural technologies. These photos depict agricultural technologies that will be applied in the future. The photo on the left shows agriculture utilizing big data. The photo on the right shows a vertical farm. By applying various technologies like these, we will overcome problems and move toward a more advanced future in agriculture. Thank you for listening to my presentation.
Okay, thank you. That's all. To the next, yeah, please.
Hello, I'm Chae-min Ho, an undergraduate student in the Department of Biological Industry Machinery Engineering. I'd like to give a presentation on the current status of agricultural machinery in Korea. This shows the sequence. First, an industry overview. When the agricultural machinery industry was underdeveloped, there were many issues. As shown in photos A and B, it depends on weather and seasons, leading to low productivity and high labor consumption. As a result, Korea's agricultural machinery industry has developed, becoming essential for improving productivity and addressing labor shortages. Figure A shows a tractor and Figure B shows a combine. Next, I'll explain the current status of agricultural machinery. First, to explain about the tractor, it is vehicle equipped with an engine used for tasks such as plowing fields and transportation. In Korea, medium and small-sized tractors are primarily used due to their versatility and ability to handle sloped terrains. Smart farming technology plays a key role in the automation of tractors and the realization of precision agriculture. I'll explain about the combine. A combine is an agricultural machine that can perform harvesting, threshing, and suppletion all at once. In Korea, small or medium-sized combines are primarily used due to the hilly terrain and limited farmland. Finally, I summarize the necessity of agricultural machinery in Korea and introduce its prospects. due to reasons such as improving agriculture productivity and work efficiency and the integration with smart farming technology to achieve precision agriculture. Agriculture machinery has become an essential tool in modern farming. Autonomous agriculture machinery as eco-friendly agriculture machines are developed in the future, it seems that they could not only grow in the domestic market but also become a thriving export industry. That concludes my presentation. Thank you for listening to my presentation.
슬라이드 쇼 어딨죠? 오케이. 감사합니다. 땡큐. Hello, I am 연정노. A second year undergraduate student who is majoring in bioindustrial machinery engineering at Gyeongsang National University. It's my first time presenting in English and it might be very clumsy because it's my first time doing this, but I will do my best to present it. It is a light topic. The table of contents is the most memorable class activity among school, department, introduction, and school life. Our school has a mascot character named GNU. So cute. It consists of a total of 5 campuses, and the department I belong to is in Gaja campus. This photo is of Bissol's student council presenting cake and flower to professor on Teacher's Day. Our department is an academic field that deals with engineering technology necessary for the biological industry. It aims to contribute to improving the productivity of agriculture and biological resources, increasing added value, improving the environmental, and increasing economic feasibility. Lastly, my school life. I rarely study my major in the first grade, and I study most of my major from the second grade. Among them, the most memorable class is Bioindustry Adventure Design. It is class of 4 to 5 people per group, and they make their one items using Arduino or Raspberry Pi. The picture is of another group, and it shows the toilet cover that goes up and down automatically using Arduino. Our group is making face recognition door looks using Raspberry Pi and face recognition modules. Thank you for listening.
Yeah, thank you so much for students from GNU to very good self-introductions of you. And for the last section, really last sections too. And then so we will move to the happy time that we have to the dinner, welcome dinner together, right? So for the last one, so I would like to invite Professor Kim, to say something and close our seminar today, and then so talk a bit to the next seminar on GNU, right, for the next year, please.
Prepare now the material, yes?
Oh, Sensei, I forgot again. So we have the last student, yes, there. So I would like her to introduce herself. Yeah. I'm so sorry, I forgot.
Hello, everyone. My name is Kochakon Bundoi. My name is Koch. I'm from Kochi University, from Faculty of Humanity of fifth year. I study Japanese, so I can speak Japanese a little bit. はい、はじめまして、風沢と大学出身のゴッチと申します。飛び入り参加という形でセミナーの途中で入ってきたんですけども、短い時間ですけれども、ここに来られて光栄です。ありがとうございました。
はい、so very 上手ですね。Japanese ね。日本語は。はい。だから、ラストは、先生、どうぞ。
Oh, thank you so much. That is, I'll use the closement is about 5 minutes and maximum 10 minutes. Then, if you know our Korean student presentation file, it without supervised name. The two present that is missing the supervised name. There is the student supervised the professor. The Joe, that is. Also, please open this. Oh, next. Only one slide is enough. That another slide is used the Yeonjeong no, as I don't experience my university and I don't want to then. This slide is only enough that our seminar workshop is occurred from 15 years ago from Kochi University. At that time, is not so much people is joined. That today is very biggest the 3-country workshop. Is the 2010 is 40. I'll visit Kochi University. The very young professor is Sato, and that maybe at that time his Sato age is the same Professor Joe as another people is that 15 years ago. Then every year the occurred the international seminar in each country. Japan and Korean. That about 2016 and 17, at that time is joined Kochi University. That from at that time is called 3 countries co-international seminar. Then it is very important and very interesting. The mean. And initially, 3 university, 3 department is not same the any topic. That today also I'm so many thinking about that. That I'm looking for the anything. The mean, the underground. I don't know what then Korean any. The Korean, what to say in English, I don't know, but yes, all same use the climate and environment. That Japan is agricultural site, so many research. Then Kasesat is forest site. That is that all combined, which is climate change and or environment. That it is okay that also another thing, initially cannot make any combine. At that time it's very easily interesting, enjoy the presentation. This is, but it's just very, very fun, very, very interesting. That after seminar is dinner party is very, very happy. That today also I believe that. Second thing is last year the Kochi University. This year today is Kasesat. Next year also GNU will organize the international conference at about November first week. The November first week is very, very good season. Like Kochi also, Jinju is very good climate, very good season. That is also justly. Please feel free join the next our co-international seminar. That again, many thanks, many thanks for also this international workshop is it's okay, not perfect. It's English is not target. English is only tool. It's not enough. It's okay. This is more important. Good is practice, learn. Also, the practice, learn is will use the next step for your future step. At that time, you can use this experience. It's very important. I'd like to continuously this conference and international workshop. Let's go to any dear future. Thank you very much.
Hi. Thank you so much for Professor Kim. Yeah, so before we left, I think I would like to give some deans of graduate school to give some small speech. Yeah, so because today, all right, so everything was support from the graduate school. Yeah, so very thank you for the graduate school too, and please say something with our participants.
Okay. First of all, thank you very much to build the environment during this day for the academic collaboration between these three universities. I hope that in the future, for the next round, I don't know where the seminar will be take place. Maybe in Korea, in South Korea, or in Japan. But this floor, you need to think about the sustainable for the academic forum like this. It can be for, today is for the climate change. For the next forum, it could be the smart technology for prevent our global from the climate change for in the future. I hope that. Today, we're very happy to be the host for this seminar, and we are look forward that you will have a good experience tomorrow, not only in the shopping mall or shopping street at Batat Thong, but also you will have a chance to visit our attractive site in Bangkok. It can be at the Wat Arun, we call, that's it, along the Chao Phraya River. And you will visit for the Grand Palace, the very famous, attractive, located in the center of Bangkok. That means you will get the experience in a scope of the tourist and graduate school at Kasetsart University will be happy to be the host for some of you maybe in the future to visit to this university again, maybe in the master degree student for the new student in Kasetsart University, or for the research exchange or scientific exchange. Everywhere, when you have a time, you have a chance to visit to Kasetsart University, feel free to go to this building. Ask for our staff to exchange some experience that you have, or to visit me. I can give you some information, maybe related on your demand. Thank you, Dr. Narumon, once again. Thank you both professor from Kyojong University, National Universities, and Kochi University. And I wish you have a good dinner together, sit together, not only for the Korean dish, and this is for the Thai group, and this is for Japan group. We need to mix together to talk with other friends from other countries, not only in our group. This is, I think it's not the aim of this forum. Thank you very much once again, and hope you have a good health and good journey and good trip back to your home. Thank you very much. It is a short word or a long word?
It's a short word too. Yeah, so from the last one, yeah, I would like to say congratulations for all of you. Yeah, to like you are successful and very like with your presentations today, and then so you like cost your word like very successful with you win with yourself, right? So right now, so you can speak in English and presentation in English too. That's why, yeah, in the next step, I think you will like use more English in your life too. Okay, so maybe this time we have to move to the restaurant to have the party together. Is this okay, right? So that you have the party. Then so we have the 2 vans. Yeah, 2 vans at maybe totally around 20%. We can go with the vans. Yeah, and after that, some persons will go there by walk, but it's not so far. It's around 10 minutes from here, yeah, by walk. So, we have to take, okay, ลืมไป Okay, so in the last one, we have to take a photo together, a group photo, because in the morning section, yeah, Professor Kim is not here. Okay, yeah, okay, so let's move to take a photo together, and then so we'll have to move to the restaurant.